रखता हूँ एक बार।
ठीक।
हम्म। ठीक है, थोड़ा सा 2-3 मिनट में लेट हो गया हूँ। सॉरी फॉर दैट। एक्चुअली ऐड नहीं हो पा रहे थे आप लोग, फिर बाद में हुआ वो काम। ठीक है। ऑल्सो यार, आज थोड़ी सी क्लास छोटी हो सकती है, कल की क्लास शायद लंबी हो जाएगी। ओके। हाँ रवि किरण, आई विल बी टीचिंग इन इंग्लिश ओनली। If I'm communicating right now with in Hindi, so please bear with me for a moment. Okay, there are a lot of students understanding Hindi only, so the mode is Hindi plus English both. Kindly respect all the languages, right? So the thing is कि आज 1 घंटे का ही क्लास में ले पाऊंगा, 2 घंटे शायद नहीं, 2 घंटे हो जाएगा, 1.5 घंटा तो हो ही जाएगा। बिकॉज काफ़ी सिवियर अभी हेडेक था मेरे को, और अभी भी है थोड़ा सा हेडेक। So थोड़ा सा आज the energy factor will be a bit on the lower side. Really sorry for that. No, actually I wanted to take rest only, but again your class is also important. This is the first day class. So I will recommend, if you haven't watched the last live session which was held yesterday, please watch that. Or if you are okay with binary tree basics, then it's fine. Hmm. Sir, this class will be continuing this time or will be changed. So basically 8 to 10 is the time. Yesterday also, today also, and the last session is for tomorrow. That will also be held at this same time. Okay. So please write in the chat if you guys are absolutely ready. If you are ready, okay. Okay, the students are ready. ठीक है भाई, करे चलो। हम्म। Can you explain implementation of generic trees? So Gaddam, actually these sessions are only for binary trees. But still I told you what generic trees are, and I told you how you can actually implement that. In the node class, except the node left and right attachments for the particular node, you can have a node array list in Java and a node vector in C++. There is no other things in generic trees. Where can we watch recording sessions? So basically, at Geeks for Geeks YouTube channel. So you have to go to YouTube and then search Geeks for Geeks, and there there is a section of videos, shorts, live. You have to go to the live section. ठीक है, live section में you will scroll down and you will find the video. There are a lot of lives that are going to be conducted. So you have to find that video in the live section. Do a little bit of scrolling, not much. There you will find the recording. Okay. The first lecture was all about the basics of binary tree. So I'll do one thing. I will just share my screen, the pen tab screen, and these are the notes actually. So for all the students who didn't attend yesterday's session, what I actually told in yesterday's session was very simple. I actually told what binary trees are, and I told what to do, how to process these things. I told what are the prerequisites for binary trees, which are two prerequisites basically. You have to know a thing or two about linked list and recursion, the basics of recursion and basics of linked list, not much. This is the class node for linked list. This is the class node for tree. So if you do not even know how to implement this node for a tree in your particular language like C++, Java, or Python, then you should watch that video, because this video is not going to help you. Also, I told about the terminologies of the tree, that what are the leaf nodes, what is the root node, what is a parent and a child, what are sibling nodes and all. So these small things not important. Okay. I told you about the null nodes, and then I coded the binary tree. This was very important. Made the connections, told you a bit about generic tree, Then the most important part about binary tree, which is root, left subtree, and right subtree. Three parts are there in a binary tree, and you have to trust recursion. These all things. I printed the tree. I told you about Euler store tree and pre-order, in order, post order. Yesterday's class was majority, मतलब the majorly on these topics: pre-order, in order, and post order. These were the important topics for yesterday. And then I gave some homeworks for you as well. These were the homeworks. And then I Okay, so please don't write on the iPad, yeah. I don't know how some of you students do not understand. Even in the last class, some people were doing these things. Please do not do these things, okay? You do not have to do all these annotations. Have some respect, okay? I am removing this. Please do not do from the next time, okay? Now, the last question that we did yesterday was size of the tree. That if you are given the root of the tree or the address of the root of the tree, then how can you actually determine the size of the tree? And it was a very simple two-liner code. Again, Kunal is doing the same shit. So please do not do these things. कहीं होगा option तो I will just अनएम्प्लॉयमेंट बहुत है यार देश में ना एक्चुअली अनएम्प्लॉयमेंट बहुत ज़्यादा है सो ठीक है सो इट इज़ माई रिक्वेस्ट टू ऑल ऑफ द स्टूडेंट्स प्लीज डू नॉट अब तो होगा ही नहीं आई हैव डिसेबल्ड द एनोटेशंस ठीक है anyways so this was the last question that I did yesterday size of the tree please tell me in the chats what was the homework that was given to you what was the homework that was given to you max yes so we have to find the maximum value in binary tree maximum value in binary tree means binary tree has a lot of nodes so the node with the maximum value we have to find that value right yes so this was your homework please tell me in the chats how you did it जिसने भी किया है so Aditya Gupta is writing the code. Return get size. He made the function get size. Root dot left plus root dot right plus one. This was the size code. I'm telling about the maximum. Return maximum left, right, current node. So yes, Sharad is absolutely correct. Technically speaking, he gave the correct logic. So traverse the entire tree and find the max. Suman is saying traverse the entire tree. So basically what you do in an array, what we do is we make a variable max. And let's say in an array, you have some values 10, 20, 30, 40, 50, 60. We keep a value max, we keep it to int minimum or -1 or the first element of the array, and then keep on updating the max variable. So technically speaking, you can make a global variable max and traverse the entire tree, travel the tree, घूम जाओ tree में जब हम print करते हैं जैसे घूमो and with each value compare the max and update the max. That can be done. But the simpler method is to just return the maximum value. So make an int return type function, right? Let me just show you what is the concept. First, let us see the concept and then the code. Okay. So for example, this is the tree. Okay, this is the tree. This is the tree. Okay. And I have a lot of values. The values can be negative as well. It depends. So for example, the value is 10 over here, then 20, then 30, then 40, then 50, then 60, and so on. Right? You can have a lot of values. What is the maximum value of this tree? It is 60. The concept behind finding the maximum value is again, the concept is similar for all the questions, by the way, right? The concept is something like this. The concept is something like this. Again, you have what? You have three parts in a tree. Please tell me in the chat किस किस को पता है और कौन बताएगा मेरे को. Who is aware of these three parts of a tree? Please tell me. नहीं नहीं, लेफ्ट रूट राइट नहीं. यस, रूट, दिस इज द रूट, this is the left subtree, and this is the right subtree, RST, right? LST, RST, and the root. So this entire thing is a tree in itself. This is a tree in itself. So what I'm trying to say is obviously the maximum will come from either this part or this part or this part. Maximum तीन में से किसी एक जगह से आएगा, या तो इधर से या इधर से या इधर से. So can I not say that the actual maximum is technically maximum of three things? ठीक है, either it is the roots value, or it is something or it is the maximum of left subtree and maximum of right subtree. This is the pseudo code. This is just an algorithmic thing. I'll change the thing in Java language. But I'm trying to say is, but what I'm trying to say is, maximum of left subtree means in this tree, what is the maximum value? 60. In this tree, what is the maximum value? 50. 60, 50, 10. Between these three values only, we will get the maximum answer. Getting it? So this is a confirmation. This is a confirmation that this is 100% going to happen. Okay, please tell me in the chat if you are getting me. Right? This is the first time I'm joining here. Akshat, I will request you to just watch the last class on binary trees. It will be available on, it is available on Geeks for Geeks YouTube channel. ठीक है, YouTube channel. You just have to go to the live section in your mobile phone or whatever you are using. Live section में scroll down. एक तो you will see the live session happening right now, which I am actually taking. There will be another video below it with my face on it. ठीक है? So that is the first video. So I will request you to watch that video. Okay. It is a program on trees basically. Yeah. So please explain once again. So students are saying, please explain. Please एक बार यार tell me in the chats that is it understandable to you, or what are the things I have to repeat again in order for you to understand. The majority of students have understood. I'll just repeat it once again. The thing is कि in a tree we have three parts. If you do not know about three parts, please leave this particular session and watch the last session. Then only you will be able to understand. जिस बच्चे ने size of the tree किया था मेरे साथ, whosoever did size of tree will be able to do this question in a second. Otherwise, you won't be able to do. So first watch this question. Okay. Now in the max value in binary tree, the answer is very simple. Either it is roots value or it is the maximum value in left subtree or right subtree. Now this thing in itself is recursion. So I know the value of root where I am standing. The left subtree's maximum value will be calculated via recursion. So it's not our headache to find that thing. It is recursion's headache actually to just find that thing. It is totally recursion's headache. It is not my headache. Okay, so this is the thing, right? इसको इधर कर देते हैं थोड़ा सा. Don't show this again, right? Okay. Now let's code. Let's code. I'm opening up IntelliJ IDEA. How to find second maximum? No, for second maximum, Anushka, actually you have to traverse the entire tree, make two global variables, and then find the second maximum. I'll show you both of the things. You have asked a very, very nice question. So the thing is, this was the size code, right? Now we will find out the maximum of this tree only. Then we will add these values and confirm if it is happening or not. Again, maximum is a number, so the return type will be int. I'm making one more function named max. Okay, yeah, max of tree also you can do it, because in C++, please make sure do not name a function max. Max is a built-in function, right? So max of tree is also a right function. Here also you can write size of tree. It will be a better thing to do. Okay, so this was size of tree anyways, and yeah, there also I didn't find out the size anyways. So let's go on to max of tree. Again, it is very simple. In three given things, roots value, left subtree, right subtree, we have to find the maximum. So you can directly apply the calls over here as well. Or what you can do is, you know that int, you can do something, you can create a variable int left max. So what, or maybe int LST max. So in the left subtree, the maximum value will be, I don't know. Recursion will find out for me, right? Recursion will find out for me. The recursion will find out for me. Okay. Similarly, you do not need to create this variable. It is just for ease of doing things. I will recommend, please, Vikas and Aman and all other people. I request you guys not to spam in the chat, okay? For all these Naukri, contest, campus, and everything. Okay, please don't spam these things in chat. Firstly, at least study whatever I'm trying to teach, okay? वैसे भी वहां अगर आप जाओगे भी कुछ हो नहीं पाएगा अगर आपको आता नहीं होगा बेसिक सवाल सॉल्व करना. And the interview questions that I'm trying to teach, right? Please do not spam. Thank you. अब इधर आ जाते हैं यार. So RST max, I'm making a variable. You can make any variable, right max, left max. It means right subtree is maximum value, which I don't know, but the recursion will find out for me. I have faith in recursion. Recursion means that, okay, if I'm calling this function with a root value, it means in that tree, it will find the maximum. I don't know how it will, it will. Okay. Now the thing is, the maximum is maximum of three things. Okay. So int, we can make answer variable, or maybe we can just return it. Even that is fine. So the thing is, we have to return the maximum of three things. In Java or in C++, you cannot directly write maximum of three values. The max function only supports two values at a time, right? So the thing is, I will do math.max. What it does is, you can only write two variables here. So for example, this LST max, comma, this RST max, right? But what I have to do is not to find the maximum of these two things, but the maximum of these two things and the roots value itself. So what I will do is, firstly, math.max of this thing. Please cut this thing. I will write math.max of roots value, comma. Please understand what I'm trying to do. So what this does is, if you ever want to calculate the maximum of three values, it is very simple. The maximum of two, and whatever is the maximum will be compared to the roots value, and then the maximum will be returned. So this is the simple answer. Again, can you tell me what will be the base case? If root is null, what am I going to return? Ayush is correct. Please tell me other students as well. Students are saying return 0. Okay, why return 0? Tell me. If I return 0, let's check. If I return 0, ठीक है, बहुत सारे स्टूडेंट्स आर सेइंग द रॉन्ग वैल्यू, बट स्टिल इफ आई रिटर्न -1 कह रहा है एक बच्चा. So if I return 0, let's see what happens. This is the tree. The values are from 10 to 70. Of course, the maximum is 70. So what if I print max of tree, and I give the root, which was A. A was the root, right? Let us see what happens. 70 is the answer. So 0 करके काम तो हो रहा है. But what if I tell you that now every single value over here is negative, then what? Then what? I don't know now what the values are. I don't know what the values are. Data can be negative. What is the highest? -10 is the highest. But if I run the code, the answer will be 0. Why? Because 0 is greater than all these values, right? So that's why what I do is, and what the base case actually conceptually tells you, base case conceptually tells you that, okay, you are technically comparing what? The roots value. But if you are at null, right? So we will give the minimum, the least value, so that if we compare that value to any value of the tree, the null's value, I want it to be the lowest, because that I do not want to return as the maximum value of the tree. That is the concept. Please remember this. Okay. So what you can do is, you can return the minimum value. In Java, it is integer dot minimum value. In C++, it is int min, int underscore min, all in capital. In your language, it will be different. Okay. So if I run the code right now, as you can see, -10 is the greatest value compared to all these values. ठीक है, this was the max of tree function. Again, you can reduce it to two lines. How you can reduce it to two lines? The LST max is technically this. So what you can do is, instead of LST max, what you can do is, instead of LST max, just replace it over here. It does not look much clean, to be honest, but it works. You can remove these values now, and let me just put it here so you can see everything. Now this is a two-liner code again, but थोड़ा सा adjust करना पड़ेगा. Please, Vivek, I am actually blocking you because you are, whatever you are doing is absolute stupidity, and it's very bad that you are not listening to me. Kind of shameful. तभी तुम लोगों की जॉब वॉब फिर लगती नहीं है और तुम बस ये भेजते रह जाते हो. अबे ब्लॉक कहाँ से करते हैं? कैसा जूम है यार ये. Yeah, let me actually coordinate with someone. He will block these students. Now it is the reality, yaar. If you are doing these things in between of a session, then how will you get placed, right? हाँ, हेलो आकाश. यार चैट में ना काफ़ी सारे स्टूडेंट्स आर ये naukri.com वाला ये सब कर रहे हैं, तो इनको ना ब्लॉक कर दो एक बार. ये चैट ना कर पाए, ताकि दो तीन ही अकाउंट है, ज़्यादा नहीं है. नाम इनके एक तो विवेक है. इसका पूरा नाम है, मैं बताता हूँ. अ, विवेक कंथला है, राइट. एक तो ये है, इसको कर दीजिए बैन. और फिर एक अमन गुप्ता है, अमन गुप्ता को बैन कर दो. और विकास शर्मा, विकास शर्मा. ठीक है, अभी के लिए इतना ही है, बाकी कोई आता तो बताता हूँ. ठीक है, थैंक यू. ठीक है भाई, ब्लॉक हो गए बंदे. ठीक है. सॉरी फॉर 2-3 मिनट्स, बट मैंने ब्लॉक कर दिया है इन छपरियों को. रियली सॉरी फॉर माई वर्ड्स, बट यही है अब जो है. तो ठीक है यार, ये साइज ऑफ ट्री का कोड है आई थिंक, और ये मैक्स ऑफ ट्री आपको समझ आ गया होगा. आपका एक होमवर्क है, यू हैव टू फाइंड द मिनिमम वैल्यू ऑफ द ट्री. चैट में बताओ कैसे करोगे, बहुत सिंपल है. यू हैव टू फाइंड द मिनिमम ऑफ द ट्री. प्रियंका इज सेइंग सर एक बार साइज का वापस एक्सप्लेन कर दीजिए. बेटा साइज ऑफ ट्री इज वेरी वेरी सिंपल. इट इज व्हाट? द साइज ऑफ ट्री इज द नंबर ऑफ नोड्स इन द ट्री. सो प्लीज टेल मी, प्लीज टेल मी, इधर एक बार लास्ट बार मैं बता रहा हूँ इस चीज को, बार बार आई वोंट टेल. ठीक है, सॉरी, बट क्लास कंटिन्यू करनी है आगे की. बच्चे बोर हो जाएंगे, फिर बच्चे स्किप कर देंगे, फिर बच्चे आगे करनी पड़ेंगे. सो इफ यू हैव टू फाइंड द साइज ऑफ द ट्री, इट इज सिंपली 1, बिकॉज दिस इज वन नोड, and then number of nodes of here, number of nodes of here. So the size is very simple. I have already written as well. Size of tree is what? Number of nodes. Number of nodes is what? 1 plus number of nodes in left subtree plus number of nodes in right subtree. This is the function. That's simple. ठीक है, it is very very simple. हाँ जी बाला कुमार, I don't know why you guys hate Hindi. I'm actually teaching in English. तब से I'm only teaching in English, right? Even if I'm doing a little bit of conversation in Hindi or all, you guys are just hating the language. It's not a good thing, यार. ठीक है, it's not a good thing. But anyways, वही तो नहीं हो जो तुम कहीं इंस्टाग्राम रील पे आते हैं, जहाँ हिंदी में लिखा होता है उसको काला पेंट कर देते हैं ऐसे बैंगलोर में. एनीवेज यार, चलो, नॉट टू ऑफेंड एनीवन. इधर आ जाते हैं. सो मिनिमम वैल्यू का कोड इज बीइंग गिवन बाय अ लॉट ऑफ स्टूडेंट्स इन द चैट. नहीं, मिनिमम वैल्यू आई नीड यार. हाँ, रिटर्न मिनिमम करंट लेफ्ट राइट सही है, ऑलमोस्ट सही है, ऑफ शरत, राइट. ओके. Abdul, please don't spam in the chat. I have seen your code, and I have actually written this code myself, right? So you need not print it again and again in this chat section, right? Hmm. So Ayush has given me the code private static int min, right? Root is equal to null, return maximum, and then min, 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 and you are absolutely correct. Thumbs up for Ayush. Ayush को shout out दे देते हैं यार. Ayush, great work, buddy. Okay. Rishikesh, also great work. ठीक है, तो हम आ जाते हैं अपने नेक्स्ट क्वेश्चन पे। द नेक्स्ट क्वेश्चन इज, इट इज द मैक्सिमम वैल्यू इन अ बाइनरी ट्री। नाउ यू हैव टू फाइंड अ वेरी वे, दिस इज अ वेरी इंपॉर्टेंट एंड अ वेरी नाइस क्वेश्चन। ठीक है, यू हैव टू होमवर्क्स, or maybe I'll tell you in the here in the class only. So the next question is, sum of all the nodes, sum of all the nodes of tree. Please tell me the approach in the chat section. So chat, I want to know the approach. So what sum of the tree means, if you have a tree like this or like anything, if you have a tree, if you have a tree, now this is a tree, you have some values 10, -6, 4, 2, 8, 13. So sum of the tree means sum of all the nodes. How will you find it? And the concept is exactly similar to the max and the size. That's it. अगर कभी भी थोड़ी सी भी तकलीफ होती है, whenever you are in a bit of pain, ठीक है, so what you have to do is, you just have to remember, you have a left subtree, you have a left subtree, you have a right subtree, and you have the node. Three things in a tree. ये थोड़ा टेढ़ा बन गया यार, बट समझ जाना. You have the node, the left subtree, root, left subtree, and right subtree. So again, sum of all nodes is what? It is what? Sum of all nodes is root dot value. Its value, not 1, 10 basically, plus sum of all nodes of left subtree plus sum of all nodes of right subtree. ठीक है, दैट्स इट. नहीं है मैक्स वैक्स, नहीं है मैक्स एबीसी. आर यू गाइज अंडरस्टैंडिंग? बहुत बच्चों ने चैट पे तो लिख दिया है. रियली सॉरी, आई इग्नोर्ड ऑल द मैसेजेस. रियली सॉरी. Priyanka is saying take any global variable. Yes, we will do the global variable root as well for maximum and sum. I'll tell you in a while. अच्छी बात है, स्टूडेंट्स आर गिविंग अनदर ओपिनियन. वेरी वेरी नाइस. सर आपने मैक्स 3 टाइम्स कैसे किया यार? ये बहुत बेसिक बेसिक चीज़ें हैं. मैथ डॉट मैक्स 3 टाइम्स कैसे यूज़ किया, उसका आउटपुट डिफरेंट होगा. नहीं बेटा, एक्चुअली मैं मतलब ये तो बेसिक्स है ना लैंग्वेज के. अब यार ये मैं क्या पढ़ा हूँ, अभी मैं ट्रीज पढ़ा रहा हूँ यार. तो दो वैल्यू की मैक्सिमम कभी भी करते हो, जैसे सी प्लस प्लस में आप करते हो, तो बेटा हम दो ही वैल्यू दे सकते हैं उसमें से. ठीक है, कई लैंग्वेजेस में 3 हो जाता है डायरेक्टली. तो अगर मेरे को 3 नंबरों का मैक्सिमम चाहिए, तो थोड़ा मैथ्स का दिमाग लगाओ ना बेटा. आप ये नहीं लिख सकते क्या ए कॉमा मैक्स और बी कॉमा सी? बेसिक 10वीं क्लास की मैथ्स है ना. 3 नंबरों का मैक्सिमम को ये नहीं कह सकते 2 का मैक्सिमम और फिर तीसरे के साथ कंपेयर कर लो. तो ये बेसिक्स है. ठीक है, क्लियर? क्लियर? इज दिस क्लियर, दिस पर्टिकुलर थिंग? हम्म. फोकस ऑन कॉन्सेप्ट्स, नॉट द प्रोग्रामिंग लैंग्वेज. ठीक है भाई, ठीक है, ठीक है, ठीक है, ठीक है, ठीक है. 5-10 बच्चे चले गए हैं, शायद स्पैमर्स चले गए हैं. ठीक है, लेट मी शेयर द स्क्रीन एंड फॉर द सेम ट्री वी विल फाइंड द वैल्यूज. ठीक है, वी विल फाइंड द वैल्यूज. अगेन इट इज़ वेरी सिंपल. अब तो आदत सी हो गई है. इसको कॉपी करते हैं. लेट मी पेस्ट दिस कोड. Here I will make sum of tree or maybe sum. So I'm making a function sum, sum, sum. So what did I say? What is the sum of the tree? It is nothing but root's value, please understand, plus sum of left subtree plus sum of right subtree. That's it. ये तो बहुत ही सिंपल था. Like this is very similar to size of tree, right? This is the sum code. This is the sum code, right? If root is null, I am returning 0. Of course, I am considering the null node to have the value 0. Matlab, I don't want its value, so I'm not adding the value. Okay, this is the sum of tree. Now your homework is to find the product of tree. Homework is find product of all elements of tree. Also, second question, you have two homeworks. You have two homeworks. Find product of non-zero elements of tree. Again, very simple. यहाँ पे please remember, I have to, मतलब I want to know from you guys what will be the base case. Like here you see the base case is 0, return integer dot minimum. What will be the base case in case of returning the product? So Revan and Sharad and Soumya and Anushka and Priyanka and Shija and Sanjana and Aishwarya and Vikas and Rudrakshi and Tushar are correct and Sakshi and बहुत सारे लोग हैं. I'm really sorry if I'm not able to take everyone's name. ठीक है? Priyanshu, Ankit, very nice. So I hope you guys understood what I'm trying to say and why the answer is 1. ठीक है, why the answer is 1 and the code will be exactly similar. चलो आपके सामने कर ही देता हूँ. So the code of the product is like this. I'm making it P product. Okay. So product of the entire tree is what? Product of, मान लो I have given, I have 3 elements. So what is the product of 3 elements? A into B into C. The sum is plus. So in product, I will just do multiplication of roots value, the product. This will, the recursion will find out the product of the left subtree, the entire product of the right subtree, and I will return 1. Why? Because if I return 0, then 0 will be multiplied with everything and the answer will be 0. So this is the product. Let us check if system.out, I will print the sum of tree as well, if it is working or not, and the product of tree as well, if it is working or not. So as you can see, the minimum maximum value is 10, minus 10. It is happening. The sum is happening as minus 280. So is it correct? Is it 280? Please check. From 1 to 7, the sum is n plus 1 upon 2. So it is 28. So 10 to 70 ka sum is 280 minus this minus 280. It is absolutely correct. And the product is this. I don't know what is the multiplication. I think 7 factorial is something like this. And the answer is coming out to be wrong. Basically, I think this is integer overflow error because the number of nodes are 7. So the answer should be negative. Okay. So sometimes these things can happen. Let's do something. Let me remove the zeros to confirm that the product is coming out to be correct. Okay. Because the product was too large. Yes. 7 factorial is 5040. So as you can see, this is the product of the tree, this is sum, and this is the largest value. Everything is happening. Okay, so for all those students, the last product that I got from minus 10 to later minus 70 was coming out to be wrong because the entire product was so big that it cannot be stored in an integer, right? Basically, whenever we make these things like int data type, int return type, and for example, I make a variable int a or int x is equal to something something. So there's a limit to which a number can be stored in an int variable. So that was crossing the limit, the product was. It is known as integer overflow. You are absolutely correct, Arav. Yes, we have to use long. Very nice. Very, very nice. ठीक है, सबको समझ आ रहा है, सब बढ़िया चल रहा है. तो दिस इज अ वेरी वेरी सिंपल कोड यार. प्रोडक्ट हो गया, ये हो गया. अब योर होमवर्क इज एक्चुअली, आई डिड योर होमवर्क विच इज नॉट अ गुड थिंग. You should have done it yourself. Now this is your homework. I will not do this thing. All the non-zero elements of the term. Again, it is very simple. You have to use some if else conditions and then it will be nice. ठीक है, तो ऐसा ऐसा आपको करना है यहाँ पे. अब let's talk about the product sum, the levels of the tree. It is the last question of this format. The format is a two-liner code of recursion. As you can see, it is so simple. Max, min, all of these things are like so simple, right? So what we will do right now is first of all, some students were concerned about the uh, global variable thing. So as you know, in the last class, I did the print code. So in print, we were actually traversing the entire tree. We did BFS, sorry, we did DFS and we did everything like pre-order, in order and post-order. So in that, if we are traversing the entire tree, what we can do is we can also make a global variable for example, static int and mx, which is storing the max, initially what we can give it, we can just leave it as it is as well, and we can initialize it before calling the print function. For example, what I can do is uh, I initialize this max as integer dot minimum value, and then what I did is I ran the print code which was printing all the values, and then I printed the mx value. The change that I did, that I will do, is something like this. Please focus on this particular code as well only. I'm creating a gap for you to understand this code. So whenever I am visiting a node, I'll do one thing. I am printing it, well and good. Before that, I can do something like this, key if the mx is actually smaller than root's value, then I will update mx equal to root's value. Okay, equal to root's value. So here also I can create, in the print function itself, I can find the, by adding one line, I can find the maximum value. Okay, let me run the code now. As you can see, I am printing the entire tree. This was the entire tree. And the maximum is printed at the very end, which is -1. Okay, which is -1. And if I do not, I am not printing, this can also happen. Do not print. Do not print. -1 is the answer. Right? I'm traversing the entire tree. I'm taking the maximum, then I'm going to left or right. Please tell me in the chats if it is clear or not. Also, we can do something like this. Key, while traversing the entire tree, we can find the sum as well. We can find the sum as well. SM. I'm making it as a sum. And every single time I'm traversing the tree, a non-null node, sum plus is equal to root dot value. It is SM. Right? Simple. So you guys are not getting it. Please, अभी मैं बताता हूँ आपको. Just give me 1 second. Just give me 1 second. ठीक है. So I am just commenting this entire thing so as to you guys ignore these things. ठीक है. Ignore these particular things. Now let me uh, please let me make you understand the things. I made the entire tree. ठीक है. Sorted है सब कुछ. I made the connections. ठीक है. Please ignore these things as well. I made global variables. These are global variables. In Java, in C++, there is another way. In Python, there is another way, whatever it is. So what these global variables do is I can access these global variables in any function, in the print function, in this function, in whatever function, and in the main function as well. I initialize the mx value as integer dot minimum value. Now, in this print function, it was a print function, right? It was a print function. Technically speaking, ये कौन सा function है? It is pre-order. It is actually a pre-order function, right? Pre-order is what? Pre-order is, let me change the name of the function. Please do not get confused. I'm just changing the name. So pre-order was what? Pre-order was something like this. Pre-order was something like this. Root, left, and right. Now, what I'm trying to tell you is whenever I was calling pre-order or in-order or post-order, essentially I was traversing. Traversing means traveling every single node of the tree, right? I was traversing the entire tree. So I am actually getting the access of each value for some time. So at that time, instead of printing, I'm trying to tell you, instead of printing, what I am doing is I am actually, please look at this, finding the maximum value. I am going to each value of the tree. Please remember, अगर आप students को आता है array में maximum value निकालना, if you know how to find the maximum value in an array, what you do in an array is you travel the entire array using a for loop or a while loop, and then in every element when you travel, you update the maximum something like this. Okay, if the maximum is less than the current value, maximum is the current value. So I am doing the same thing in the tree, but in the tree, what you do is actually traverse using recursion. So instead of printing, I'm finding the maximum value. And at the same time, I can actually find the sum of the tree as well. Initialize the sum as 0. Okay. Initialize the sum as 0. SM is equal to 0 over here in the main function. ठीक है, यहाँ पे तो I just have declared the variables. I have declared the variables. इधर देखिए. I have initialized the sum, initialized the max, and then you can actually find the sum of the tree as well, because whenever I'm traversing the tree, I am adding the roots value to the sum. Please tell me in the chats अगर आपको सब समझ आया है. Yes, Sai, actually I have initialized in the main function before calling pre-order. Then I have called the pre-order, which is essentially doing everything. Okay. Here only I have done this thing. So you can calculate product, sum, maximum, minimum, everything. Okay. Everything. You can do it from here only. Okay. Except some things which I'm going to tell you. Can we call also pre-order with this? So actually this is pre-order only. I think you are talking about post-order. Again, it does not matter. It does not matter. Okay. So whatever I do, this is pre-order. Even in order, this is in order because left work, right, right. This code will work. This code will work. It will calculate the maximum value and the sum. It does not matter. It does not matter. This essentially becomes in order. So let me make it pre-order again. Even in post-order, it will work. It will work. It is nothing. I am just doing pre-order. यार जिन बच्चों को ये समझ नहीं आ रहा, you have missed the last class and it is a very bad thing. Please watch the last class. I have in detail told you the code of pre-order. What I'm trying to tell you, in pre-order I visit entire tree. So pre-order में मैं यहाँ पे print करता था. I used to print the value. I'm not printing now, but I'm visiting. So I have the value of the root, right? So I'm just taking the maximum at that time and updating it and updating the sum as well. Nothing else. ठीक है? Yeah. The concept is to just traverse it fully. Does not matter कैसे traverse कर रहे हो आप. Correct. ठीक है. Let's move on to the next thing. Now I am actually commenting this code and these 4 codes are important. ठीक है. तो ये आप सबको समझ आए. Max, min, size, product, sum and all. There is one more code which is very very important. It is the height of the tree or the levels of the tree. I am teaching you levels first. Height is very simple. ठीक है. So a very important concept is the levels of the binary tree. Levels and height both actually, but height is same. Levels of binary tree. ठीक है. Now what do you mean by, what do I mean by the levels of the binary tree? I'll tell you. फिर sensations करने लग गई यार ये आईपैड वाली स्क्रीन. क्या चल रहा है यार ये. मतलब महंगा महंगा चीज खरीदो तो फिर ऐसा होता है. एनीवेज थोड़ा सा मेरे को दिखेगा कम बट कोई नहीं. ठीक है. तो दिस इज द ट्री. ठीक है. लेट मी मेक अ ट्री फॉर यू. तो फॉर एग्जाम्पल आई हैव दिस पर्टिकुलर ट्री. ठीक है. आई हैव दिस पर्टिकुलर ट्री. दिस इज अ बाइनरी ट्री. इट इज, यस इट इज. ओके. नॉट लेवल ऑर्डर ट्रावर्सल हार्दिक. प्लीज अंडरस्टैंड लेवल्स ऑफ अ बाइनरी ट्री क्या होता है. प्लीज मेरी बात सुन लो. ठीक है. So this is a binary tree. It has some values. I don't care about the values right now. Level of the tree means something like this. This is the first level, beta. ठीक है. This is the first level. This is the second level. This is the third level. This is the fourth level. This is the fifth level. Are you guys getting it? What do I mean by levels? So draw the tree nicely also so that you can understand, because please do not do something like this, that this is the tree. Okay. If you do something like this, yes, is it a binary tree? What I made right now? It is a binary tree, but the levels are 3. So please make these dashes edges of the tree. These are known as edges, by the way. These are edges of the tree. This is an edge, 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 edges of the tree. Kind of equal in length. Okay, or maybe in this length. So the levels of the tree are 5, right? Also, there is a connection to height of the tree. Levels of the tree, basically 1 plus levels is actually not 1 plus levels, levels minus 1, or I'll check. The height of the tree is basically this. This is 1 height, 2 height, 3 height, 4 height. So the height of the tree is actually levels minus 1. Okay. Height of a binary tree is nothing but levels minus 1. Now please understand, अगर आप मुझसे पढ़ रहे हो, you are studying from me. नेवर इन योर लाइफ विल यू एक्चुअली कैलकुलेट द हाइट ऑफ द ट्री. मतलब यू आर, मतलब आपसे पूछा जाएगा हाइट बताओ, what you will do is you will calculate the levels and just do a -1. That's it. Because this is much easier. Much easier, I am telling you. Much easier to calculate levels. And then -1, so you can do it. Right? So, no, both are same. Height and level are not the same. Actually, height is levels -1. ठीक है, सेम नहीं होते unfortunately. This is not same. ठीक है. So please remember this thing as well. But we are concerned about levels right now. So how will we calculate the levels of the tree? Can anyone tell me in the chat, sir, why -1 is doing there? Basically, height of the trees, please listen and look very carefully. The height is this. This is 1, this is 2, this is 3, this is 4. So basically, height, you can say, is the height actually. Like if this is the ground floor, this is first floor, this is second floor, this is third floor, then this is fourth floor, right? So the number of levels are actually 5, but the height of the building is 4. Getting it? This is the concept. Okay. So Shubham is writing an answer 1 plus maximum of level left, level right. ठीक है. नहीं आदित्य यार, डीएफएस बीएफएस मैंने कल बहुत अच्छे से बताया था आपको. डीएफएस इज प्री ऑर्डर, इन ऑर्डर, पोस्ट ऑर्डर. कल आपको बहुत अच्छे से कराया था. प्लीज उस सेशन को जाके देखिए, बार बार मैं नहीं पढ़ा सकता वो चीज. प्लीज अंडरस्टैंड. ठीक है. ऑल्सो अब लेवल 0, लेवल 1, लेवल 2 इज काइंड ऑफ, क्या कहते हैं उस चीज को, it is a comparable term. So some people say that it is the first level, it is the second level, it is third, fourth, fifth. Some people say that okay, it is 0, 1, 2. It depends on the question you will be given. Okay. Now please tell me, यहाँ पे हम क्या करेंगे? What we will do in this question? What will we do in this particular question to find out the number of levels of the tree? So please understand. Please understand. I am writing a logic. I am writing a logic. For example, मैं यहाँ पे खड़ा हूँ. I'm standing over here. So if I am at a root, so of course for एक level तो यही हो गई. You have one level, right? You have one level. Now please tell me this left subtree and in this right subtree, what are the levels of the right subtree? Only 2 levels. What are the levels of left subtree? 1, 2, 3, 4 levels. So what will we choose for the entire tree? Left subtree, 4. Please understand this thing. Sometimes the tree is not balanced in shape or looking nice, like the example that I usually take. So you are getting a binary tree like this. Okay, this can be a binary tree. Yes. In fact, this is also a binary tree. This is a very interesting binary tree, a degenerate binary tree. Okay, this is a binary tree. This is null, 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 and null. Okay, so again, the levels here are 5. But the code, I told you the logic. Now the code is very, very simple. The total levels of the tree, the total levels are very simple. They are 1 plus you have to return 1, the level you are standing at, plus maximum of levels of left subtree and levels of right subtree. Please understand. I am doing 1 plus maximum of this. So for एक level जिसमें हम stand हो रहे हैं, बाकी इन दोनों में से जो maximum है उसको I will consider. That's it. One liner code. What will be the base case if the root is null? It will be 0. That is why we use levels. ठीक है. तो for example, we are here at null. So if the tree is nothing, basically, for example, I have this tree. It is a tree. Its left is null, its right is null. The value is 10. It is a very small tree of 1 level, right? So what I do is 1 plus maximum of this and this. So the null is considered as 0. ठीक है. यहाँ पे we will simply return 0. And also, यार, I would recommend you guys to understand the concept of the base case also. ऐसा नहीं है कि you are mugging it up. ऐसा नहीं है कि आप रट्टा मार रहे हो कि you know the levels, everything, whenever I am reaching the base case, root is equal to null, return 0. ऐसा नहीं होता. In particular questions, we have to think what is the base case. Like here, I thought of the base case and then I returned 0. In the sum code, sum of the tree, the return was 0. Size, the return was 0. right? Maximum the return was not 0. Amarjeet is saying no audio. Can you guys confirm? Sir, what is the height of only one node? I will tell you. I will tell you. एक बच्चा गोली दे रहा था फिर मेरे को anyways. I will tell you the height as well. Height will be 0. Levels -1. Now the thing is, some students have this doubt कि I am coding the levels thing. Can you not directly code the height? No, you cannot. मतलब you can, but it will be very troublesome. Okay. So usually it is recommended कि first find the levels of the tree and then use a -1. ठीक है, तो फॉर एग्जाम्पल दिस इज द ट्री, so the height is just 1, the levels are 2. Okay, silly question, if root is null then height is -1. Yes, मतलब the height is also 0 actually. If root is null then you use a separate case की height is 0. ठीक है, ऐसा नहीं है कि height -1 होगा. ठीक है, प्लीज एक्सप्लेन वाई लेवल -1, वाई -1. अरे मेरे बच्चे, the levels are 5. Can you understand levels are 5 or not? Please tell me in the chat. ठीक है, can you understand? These are 5 levels. Very, very simple. The height is this 1, 2, 3, 4. Between levels. If this is the ground floor, first floor, second floor, third floor, fourth floor, the building is of 4 floors. The height of the building is considered as 4, right? But the male, the actual levels of the building are 5. Okay. साईनाथ, फिर आप पूछ रहे हैं यार भाई साहब, क्या करूं अब मैं इसका. अब मैं कुछ नहीं बता रहा हूँ यार, आप छोड़ के जा सकते हो. सॉरी, सॉरी, अब आई वोंट टेल. ठीक है, इट इज अ वेरी वेरी 10th क्लास कॉन्सेप्ट. यू शुड अंडरस्टैंड बेसिक थिंग्स. ठीक है, व्हाट आर लेवल्स एंड व्हाट आर हाइट. इसमें भी अगर आप कॉन्सेप्ट सोचोगे तो पता नहीं मैं क्या करूँ फिर. ठीक है, डायमीटर ऑफ द ट्री अभी करेंगे थोड़ी देर में, बहुत इंटरेस्टिंग है वो. ठीक है, ओवरऑल हाइट कंसिडर्ड फ्रॉम 0 लेवल. यस. तो ब्लॉक दी स्कैमर्स. अरे यार, एक एक करके बहुत टाइम लग जाएगा. एनीवेज, सो लेवल वाला जो कोड है वो भी हम कर लेते हैं. लेवल वाला कोड है वो हम कर लेते हैं. लेट अस डू द कोड ऑफ लेवल वाला. ठीक है, सो अगेन आई विल कॉपी पेस्ट. आई विल कॉपी पेस्ट. किसी को भी उठा लो यार, किसी को भी उठा लो, सम को उठा लेते हैं. कॉपी करते हैं, पेस्ट करते हैं. लेवल्स, व्हाट आर द लेवल्स? रूट नल रिटर्न 0. Levels are 1 plus. In Java, it is math.max. In C++, it is max. So what? Levels of left subtree. तो क्या हो रहा है ये? हाँ, comma levels of right subtree. That's it. 2-liner code. ठीक है, so tell me what will be the levels of this tree. Can you guys tell me before even printing it? Before even printing it, can you tell me the levels of this tree? 4. 4 है. भूल गए? This was the original tree. 3. This was the original tree. Okay. This tree, like what I made yesterday. जो मैंने अभी बनाया है उसकी लेवल्स 5 ही है. ठीक है, this has 5 levels. So this has 1 2 3 4 levels. This has 3 levels. Okay, तो यही ट्री था, बस -1 -2 -3 ऐसे ऐसे करके था, ऐसा ऑलमोस्ट इधर भी था. ठीक है, तो 3 लेवल्स. ओके, 33 नहीं, 3 है भाई. जयंत, डू नॉट स्पैम. ले लिया आपका नाम, शाउट आउट दे दिया आपको. हाइट इसकी 2 है. ठीक है भाई, तो ये हो गई लेवल्स. सो अगर मैं अभी समराइज आपके सामने करूं, हमने अभी तक क्या क्या पढ़ा है, व्हाट ऑल हैव वी स्टडीड टिल नाउ. सो अगेन, बेसिक्स ऑफ बाइनरी ट्री, व्हाट इज अ बाइनरी ट्री एंड ऑल. देन वी अंडरस्टूड एक्चुअली द ट्रावर्सल पार्ट, which is PFS, pre-order, in-order, post-order, all three. Pre, in, post, we understood this. We understood the recursion part, the node class and everything in the basics. Then we did, I call it size, sum, max and levels. These four things. Because the product and sum are similar, max and min are similar. levels and height are similar. ठीक है, so these are the four very very important codes. इसके बाद अब ट्री ना बहुत क्लियर हो जाता है. अब ट्री इज वेरी वेरी क्लियर. So finding the question, solving the questions of tree are very very simple right now, because now you know a tree consists of root, left subtree and right subtree. So every single thing is easy. नहीं अंशिका, आई एम नॉट इन दैट सिग्मा सिग्मा बैच. ओके, आई वाज नेवर अ पार्ट ऑफ दैट इन फैक्ट. एनीवेज, तो इधर आ जाते हैं, आप थोड़ा आगे बढ़ते हैं. एंड अब आगे देखते हैं कि आगे क्या क्या पढ़ना है. पहले यू कैन सी द कोड्स, यू कैन टेक द स्क्रीनशॉट ऑफ दीज कोड्स एज वेल. ओके, दीज आर द 4 5 कोड्स. प्रोडक्ट को साइड करते हैं यार, अब आई एम रिमूविंग दिस. प्लीज राइट इट योर सेल्फ, मैक्स साइज सम लेवल्स. एंड लेट मी मूव अहेड and let's talk about some questions. Give me 1 second. We already did pre-order, in order, post order. ठीक है. Hmm. So now we will do some very very interesting questions. Very very interesting questions in fact. ठीक है, very very interesting questions. Diameter of the tree and all. But the first question is invert a binary tree. Sometimes it is asked in Amazon as well. Sometimes it is asked in Amazon as well. मतलब आप तो नहीं पूछते. थैंक यू चिराग, थैंक यू वेरी मच. इधर आइए. Now we will do some questions. So question one is actual questions. Invert a binary tree. Let me tell you the problem statement of the problem statement, and then we will solve the question. Also, we can solve the question in lead code platform as well. But let me show you the lead code platform. Give me 1 second. Give me 1 second. Okay. Let me open it. So नॉट लीड कोड, हम तो गीक्स फॉर गीक्स में आ चुके हैं ना. रियली सॉरी, आई फॉरगॉट. ठीक है, गीक्स फॉर गीक्स के प्लेटफॉर्म पे ही करेंगे ना यार. इन्वर्ट बाइनरी ट्री जीएफजी. हम्म. ठीक है. सो यू कैन रीड द आर्टिकल एज वेल. आई एम शेयरिंग द स्क्रीन. मैं भी ना यार, कितना भूला हूँ. यार स्क्रीन शेयर क्यों नहीं हो रही यार. अब हो रही है. प्लीज टेल मी इन द चैट्स इफ यू आर एबल टू सी द स्क्रीन. बता दो प्यारे बच्चों. हाँ यार, एरियल बाइनरी सर्च ट्री होता है टेक्निकली, सेल्फ बैलेंसिंग. पूछा नहीं जाता हालांकि इंटरव्यूज में इतना. ठीक है यार. सो दिस इज द क्वेश्चन, इन्वर्ट binary tree. The problem statement is very simple. If you have this binary tree, then you have to take the mirror image of it. So if this is a mirror, then the new tree which I want will be something like this: 1 3 2 4. Okay, this is invert binary tree. We will solve it on GfG practice as well. Like, this is also a binary tree. So what invert does is, it is a very important thing. What invert does is, it is not just swapping the left and right subtree. I am giving you a hint. I am giving you a hint. In this particular tree, if I just change the connections, we will also learn changing the connections. We can change the connections. If I made the left subtree to the right and the right subtree to the left, then you can see something is happening. But it is not exactly that, because 2 4 5 is also getting changed to 2 5 4, right? So everything is getting inverted. ठीक है, we'll write the code, we will solve it on GfG practice. I hope you guys know GfG practice. It is a very 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 basic and simple easy level question. Okay, so I am using Java. You can use C++ as well. Void mirror. Again, you have, this is a void code. You do not have to return anything. You are given a node. I will change the name to root. It is your choice. आप इसका नाम कुछ भी रख सकते हो. ठीक है, आप इसका नाम प्रियांशु भी रख सकते हो, एक बच्चे का नाम है. आप इसका नाम साक्षी भी रख सकते हो. इसका नाम आप राघव भी रख सकते हो. ठीक है, वट एवर यू विश टू. नाउ लेट्स गो टू द आईपैड स्क्रीन फर्स्ट. जिन भी बच्चों को आता है, वेरी नाइस. यू कैन जस्ट वेट. or maybe see my solution. Screen is not showing anything rather than geeks for geeks. Okay, now is my screen visible to you? Invert a binary tree. Okay, ठीक है. So the concept is clear, but there are some things that I need to tell you. Now, for example, my tree is something like this. अच्छा बनाते हैं थोड़ा ना, ऐसे नहीं. Last class में I remember I made a beautiful tree. Okay, this was the beautiful tree. Okay, copy. ठीक है, and paste. जब बना ही रखा है तो उसको यूज करेंगे. So this is the binary tree. What do you actually mean by inverting the tree? What do you mean by inverting the tree? And I'll remove this node for some kind of better understanding purpose. ठीक है? This is the binary tree. You have to change it, invert in it such a way. I will show you the algorithm first. ठीक है? Let me copy the tree. Both of them are absolutely same, right? They are absolutely same. Please ignore this tree for a moment. Ignore this tree and look in this tree. I will actually invert the tree. Invert के अंदर what is happening is something like this. 10 will be the leaf node. No, 10 is not the leaf node, beta. Here 10 is the root. These are all the leaf nodes, right? It is a very basic concept. Anyways, इधर देखो, please see this particular tree. What I do is something like this. I have root, I have root, I have root. So this is root dot left, this is root dot right, right? So what I do is I make the root dot left as root dot right, and root dot right, I'm actually swapping root dot right as root dot left. And not just for this particular thing, because these are not mirror images. Please confirm these are actually not mirror images, because 10, 30, 40, 60, 10, 30, 60. Like this is happening, but this is not mirror image. 60 should be lying over here. So I do it for every single node now. I have done it for this node. This has been reversed. Now let's talk about this node, 30. So 30 is right is null, 30 is left is 60. Please remember, actually 30 is right was not nothing, it was null, and 30 is left was 60. So I actually swap them as this. So now this work has been done. Now in this 20, what we do is again, I swap the nodes. You have to swap the nodes and not the values. Now you can see it kind of, you can also remove this. It is the same thing. These are absolutely mirror images of each other. Okay. Please tell me in the chat if you are able to understand this. I'll show you how to swap the nodes. It is not a big deal. It is not a big deal. So, अब आप करोगे क्या? What you will do is, there were two concepts. ठीक है, only one concept actually. You have to visit every single node, right? You have to visit every single node, and then you have to swap its left and right node. Not swap, it is like ki, take the left subtree and connect it to the right subtree, right connection. Take the right subtree and connect it over to left subtree. Also, I traversed the entire tree. The leaf nodes were actually, you can see they are kind of missing right now. They are missing right now, but in the leaf nodes, if both are null, they can be swapped easily. And whenever you, there will be no change. And whenever you need reach null, you can just simply return. It is a void function. So you do not have to do anything. Okay. Yes. So I can go to the coding screen for you guys to understand. Let's go to the coding screen. Okay. Is it visible? Is the GfG thing entirely visible? Please tell me. Is the GfG thing entirely visible? Tell me in the chat. ठीक है, yes, it is visible. ठीक है. So अच्छा, एक और चीज, if you are actually using these kind of online judges, like online platforms to code, please remember you are only filling this function, you are not making the main function and all. I think you guys know already. And the thing is ki please see the binary tree node on all the platforms. Like in some platforms, it is written as binary tree node, right? It is written like something like this. The node's signature is Binary tree node, linked list node. There is a platform which does this shit thing. So it is very bad. So in GFG, at least it is simple node. And please remember in node, it is not int val, like I did val, right? But here it is data. It is data. So please remember, it is left right का तो वही same है. Data है. So you have to use data whenever you have the question. ठीक है? Yes, tree node in lead code. एक जगह तो it is binary tree node as well. ओके, हेयर इट इज नोड ओनली, तो अच्छी बात है। चलो चलो आ जाते हैं, तारीफ नहीं कर रहा जीएफजी प्लेटफॉर्म की, बट अच्छी बात है, कुछ कुछ तो काफी चीजें अच्छी है। ठीक है, वॉइड मिरर, सो यू हैव टू एक्चुअली मिरर दिस ट्री। मिरर ट्री नाम से क्वेश्चन है, इट इज इन्वर्ट ऑफ अ बाइनरी ट्री एज वेल। सो व्हाट आई वाज डूइंग इज, प्लीज रिमेंबर, फर्स्ट ऑफ ऑल आई हैव टू ट्रेवर्स द एंटायर ट्री। मानते हो इस बात को? यस। And I have to traverse the entire tree. And for each node, I have to swap left and right. Now, the problem with swapping is, for example, I am in this root. I simply do this. Root dot left is now root dot right. So what it does is कि now the left connection has the right subtree. ठीक है? So left has now the right subtree. Please remember. ठीक है? ये करने से ये तो हो गया. But the thing is, the entire left subtree is now gone. It is gone. Okay. The left subtree is now connected to nothing. So it is randomly hovering in space. So we have to save it. It is simply like when we swap two numbers, right? So we do int temp is equal to A is equal to B is equal to temp. So again, we will do a node temp is equal to root dot left, so that the left subtree is with us. Now in the left part, we have the right subtree, and then in root dot right, we actually connect temp. Okay. डार्क मोड सर, यार वो डार्क रीडर डाउनलोड करना पड़ेगा। कर देता हूँ वैसे तो। अच्छा, जीएफजी में ऑप्शन भी होगा यार, क्यों नहीं होगा? ये तो रहा, अरे भाई सॉरी। ठीक है, सॉरी योर आईज वर बर्निंग, रियली सॉरी। दिख रहा है आपको? कहाँ गया मेरा कोड, कहाँ गया? अ, कुछ दब गया क्या मुझसे? एक सेकेंड यार। स्क्रॉल, चलो नीचे स्क्रॉल कर लेते हैं। अच्छा वो ऊपर आ गया था, एनीवेज वो ऊपर की चीज नहीं दिख रही। तो दिस वाज द फंक्शन, अनफॉर्चुनेटली सब गायब हो गया यार। बड़ी गंदी बात है तो यार। ठीक है, तो वापस से नोड लिख लेते हैं। वापस से नोड लिख लेते हैं, इधर आ जाते हैं। ये इसका कोई तो ऑप्शन होगा यार, इसका कोई तो ऑप्शन होगा। इज देयर एनी ऑप्शन? यू एक्सपेंडेड द मेन फंक्शन। वेयर इज द मेन फंक्शन? इज द मेन फंक्शन, सो आई कैन जस्ट एक्चुअली, ठीक है, ये भी चलेगा। ठीक है, तो आर कोड इज हेयर। what I made is a node temp which is storing the left subtree. So root dot left, the left has now the right subtree as connection, and roots right is now temp. Okay, so this was the swapping part. The second part is, अभी के लिए what I did was just the swapping of the left and right subtree. अब उनमें भी eventually I have to mirror the things, right? So what I'll do is I'll call this function again recursion. It is not root sir, it is node. ठीक है, तो इसको root बना दो, ये लो, क्या प्रॉब्लम है? ठीक है, यहाँ root बना दो। ठीक है, so I will now mirror the left subtree, which is the right subtree, but anyways it does not matter. I am actually mirroring both. I have to mirror this and I have to mirror this. That's it. The base case is if root is equal to null, just return. Okay, just return. Or basically, if it is a leaf node, there can be another base case as well for you for ease of use. Okay, so what you can actually do is something like this key. If the root is not, it is a leaf node. Leaf node is when your left is null and the right is null and the root itself is not null, then you can also return. But anyways, not bad. This is the code. ठीक है, टाइम कॉम्प्लेक्सिटी बिग ऑफ एन, वी शुड सबमिट दिस कोड। कितना छोटा कोड था ये देखो। Arav, I just gave the diagrammatic explanation of this code. I don't know what you are talking about. I just gave the diagrammatic representation of this particular code. ठीक है, एक और बार आपको दिखा देता हूँ। आई डोंट नो आपका ध्यान कहाँ है। इधर आइए भाई। हम्म वापस से एक बार दिखाऊंगा आपको। सो दिस इज द ओरिजिनल ट्री। ठीक है, दिस इज दी, लिख देता हूं मैं आपको, ओरिजिनल ट्री। हाउ इट इज वर्किंग इज आई एम मेकिंग अ कॉपी। इसके अंदर में हम चेंजेस कर रहे हैं, मैं आपको फॉर रेफरेंस दिखाना चाहता हूँ। व्हाट आई डिड इज, मैंने दो स्टेप्स किए। सबसे पहले हम जहाँ पे है, अभी हम इधर है बेटा, अभी हम इधर है मान लो, ठीक है। अभी हम इस पे है, तो इसका लेफ्ट सब ट्री और राइट सब ट्री को मैंने कर दिया सिंपली बेटा स्वैप। इसको पटका, टेम्प वैम्प में रखा, इसको बेटा इधर रखा, इसको ओ शिट, एक सेकेंड, इसको मैंने इधर रखा, इसको मैंने इधर रखा। आई स्वैप दीज थिंग्स, आई स्वैप दीज थिंग्स। दिस इज द फर्स्ट स्टेप। Now the second step is to actually do this thing for every node. I have done this thing for this node only. Only this node. I have to swap and do for every node. So I will visit every node. I will use pre-order or post-order or whatever order. Not whatever order. I am actually using pre-order only because first I did swap for this and then I swapped for the remaining. So I went here. Here I again swapped for two things because this is null, because this is actually technically, this is null. So what I did is I swapped these both. Okay. So its work is done. Then I actually went here. It was null, so return ho gaya. Then I actually went here. So the child nodes of 60 were null and null. So actually what happened was both of the nulls were swapped. Okay, and then I went to null and null and their work was also done. I do not need to show all these things. Okay, then I actually went over here. Okay, because in pre-order sense, and then I swapped these and all. बस इतना ही काम है आपका, दैट्स इट। हो गया यार डायग्रामेटिक विजुअलाइजेशन। वन लाइनर वुड वर्क, यस इट कैन वर्क, इट डिपेंड्स अपॉन द लैंग्वेज। आपका कोड बिल्कुल परफेक्ट है, कोई दिक्कत नहीं है। नहीं, what you're doing is actually wrong, I feel. It is not wrong. It is not wrong. It is wrong. Because आपने जो कोड लिखा है चोपड़ा, is कि आप स्वैप कर रहे हो मिरर और ऑफ लेफ्ट और राइट. So you are actually applying recursion, and for example recursion is working. The left and right are being mirrored in themselves, and then they are swapping. तो ऐसे स्वैप होगा नहीं क्योंकि दो कॉल्स को स्वैप कर रहे हो आप. प्लीज रिमेंबर दे आर void calls. You are swapping the calls. Okay. सर एक बार रिकर्सिव पार्ट एक्सप्लेन कर दो बेटा मेरे प्यारे चिराग, प्यारे चिराग। रिकर्जन का मतलब आपने कल की क्लास में नहीं समझा है और बहुत ही गंदी बात है। ये समझ गए इसका स्वैप कैसे किया? इसके पर्सपेक्टिव से मैंने इन दोनों को स्वैप कर दिया, इसमें तो रिकर्जन नहीं लगी, है ना, नहीं लगी ना। तो रिकर्जन का क्या मतलब है कि जो काम मैंने इसके लिए किया, अब जब मैं कॉल कर रहा हूँ लेफ्ट सब ट्री और राइट सब ट्री को, तो रिकर्जन अपने आप यही सेम काम कर रहा है लेफ्ट और राइट के लिए। प्लीज कल की क्लास देख के आओ वरना आपको नहीं समझ आएगी चीजें। ठीक है, और मैं कल की क्लास के बारे में आपको यार नहीं एक्सप्लेन करने वाला हूँ, प्लीज ट्राई टू अंडरस्टैंड। देयर आर अ लॉट ऑफ स्टूडेंट्स हु religiously attended the yesterday's class, so it will be unfair for them. This is the code again. कौन से कॉन्सेप्ट्स है बेटा? दिस इज बेस केस, दिस इज द स्वैपिंग रूट का लेफ्ट सब ट्री और राइट सब ट्री को, दिस इज रिकर्जन. What these calls are doing is, because they are void calls, please remember, what these calls are doing is, now recursion is actually inverting this left subtree and the right subtree. Now I am not doing it, recursion will do it. So have faith in recursion and please understand actually में ऐसा क्यों हो रहा है, उसके लिए watch the last lecture. बढ़िया समझ आ रहा है तने? कैन यू एक्सप्लेन द बेस केस ऑफ रूट डॉट लेफ्ट एंड रूट डॉट राइट? बेटा बेस केस लेफ्ट और राइट का थोड़ा होता है, वो तो रूट का ही होता है। अगर मैं नल पे आ गया हूं तो नल का कोई लेफ्ट और राइट तो होगा नहीं, तो आई डू नॉट हैव टू इन्वर्ट इट, राइट? Null has no left no right, so I'm just returning. And if a node is a leaf node, like its left and right both are null, so again I'm swapping both of them. It does not matter, null and null are getting swapped, it does not matter. Okay, the previous classes are there on Geeks for Geeks YouTube channel. हद हो रही है यार तुम बच्चों की। तुम क्या कर रहे हो? बीच बीच में आते हो क्या लाइव स्ट्रीम के? 1 करोड़ बार तो तुम्हें बता दिया गया। आई होप दिस इज विजिबल टू यू गाइस। आई एम टेलिंग दिस वंस एंड फॉर ऑल, द लास्ट टाइम आई एम टेलिंग यू। दिस इज गीक्स फॉर गीक्स यूट्यूब चैनल। यू गो टू लाइव सेक्शन। इतना बेसिक आता है, आई थिंक आप लोगों को, इतने समझदार हो, बच्चे नहीं हो। होम इसको वीडियोस कहते हैं बेटा। इसको शॉर्ट का सेक्शन कहते हैं बेटा। इसको लाइव का सेक्शन कहते हैं। देखो मेरा चेहरा भी दिख रहा है यहाँ ठीक ठाक सा। ठीक है, यहाँ लाइव सेक्शन में आते हैं हम यहाँ पे। ये सारी वीडियोस को आप इग्नोर करो या इग्नोर मत करो, अगर आपको ये सीखना है तो सीखो, इन सबको हटाओ। दिख गया मेरा थोपड़ा यहाँ पे? दिख रही है शक्ल? ये कल की लाइव है जो कल होगी अब। ये दिख रही है लाइव, ये अभी चल रही है बेटा। ठीक है। यूट्यूब चलाना सीखो। और ये वो क्लास है जो हो चुकी है 22 आवर्स अगो। सो दिस वॉज द फर्स्ट सेशन। दिस इज द सेकेंड सेशन जो अभी चल रहा है, एंड ये लास्ट सेशन है। थर्ड लास्ट। ठीक, थर्ड एंड लास्ट। ठीक है। ये कल की वीडियो है, प्लीज जाके इसको देख लो। ठीक है, काली शर्ट पहन रखी थी इसमें मैंने, ये आपको दिख जाएगा। थैंक यू वेरी मच। आई होप सबको अब यूट्यूब चलाना आ गया है। ठीक है। अबे रोस्ट नहीं किया, मैं बता रहा हूँ क्योंकि मैं बहुत बार बता चुका हूँ तुम्हें। जीएफजी चैनल पे जाना है, लाइव सेक्शन पे जाना है, मेरी वीडियो ढूंढनी है। इसमें भी आपको ट्यूटोरियल करके दिखाना पड़ रहा है। आप तो फिफ्थ क्लास के बच्चों की तरह बिहेव कर रहे हो, जब जब लैपटॉप और कंप्यूटर चलाना नहीं सिखाते कि ये लो सब्सक्राइब भी कर देते हैं। सही बात है भाई। ओ भाई, नौकरी वोकरी से निकाल देंगे मेरे को यार, क्या पता। बोलेंगे भाई तो कैसा आदमी है, खुद को ही सब्सक्राइब नहीं करके बैठा है यार। हद हो रही है। ठीक है। चलो, अब यहाँ कोई वीडियोस भी दिखेगी तुम्हें, धीरे धीरे करके मेरी भी। अभी इन मैडम की आती है वीडियो, इन सर की भी आती है, इन भाई साहब की भी आती है, मेरी वीडियो भी दिख जाएगी, मालिक की भी आती है। चलो, अब आ जाते हैं हम मिरर ट्री पे। ठीक है। लाइक शेयर सब्सक्राइब गाइस। ठीक है। एक बार चैट में बता दो आज का सेशन समझ आ रहा है, चीज़ें समझ आ रही है, क्वेश्चन समझ आ रहा है, फिर हम नेक्स्ट क्वेश्चन पे आएंगे जो कि अगेन एक अच्छा क्वेश्चन है। नेक्स्ट क्वेश्चन का नाम है सेम ट्री। ओपी है, बिल्कुल है। ठीक है। आप बच्चों ने वैसे मेरे को टेक्स्ट नहीं किए थे कि आपको चीज़ें समझ आई नहीं आई। बड़ी गंदी बात है तो यार। हैं? उसके लिए मेरे को क्या माइक्रोसॉफ्ट से या फिर गूगल से इंजीनियरिंग करनी पड़ेगी? ये बताओ। एक भी बच्चे ने मेरे को सोशल पे टेक्स्ट नहीं किया भाई। एक भी बच्चे ने नहीं किया भाई, एक ने भी नहीं, मतलब एक ने किया होगा शायद, एक ने भी नहीं किया। ना एक ने फॉलो किया, बताओ। बट एनीवेज चलो, मेरा काम तो पढ़ाना और तुम्हारी प्लेसमेंट लगाना है, वो ज़्यादा जरूरी है। हम आ जाते हैं शेयर सेक्शन पे। इधर। अच्छा, लिंक्डइन पे गया? लिंक्डइन कौन खोलता है? तो खोलना चाहिए, तो मैं मजाक कर रहा हूँ भाई। मेरी आदत खराब है। लिंक्डइन बढ़िया है। लिंक्डइन पे तो मेरे फॉलोअर्स ऐसे ही बढ़ते रहते हैं, पता नहीं क्यों। जहाँ मैं चाहता हूँ इंस्टाग्राम पे, वहाँ बढ़ नहीं रहे। लिंक्डइन पे फ्री में बढ़ते हैं ना, मैं कंटेंट पोस्ट करता हूँ ना मैं कुछ। हाउ डू यू डील विद बेस केसेस? यार दे बहुत ही प्यारा क्वेश्चन है, और मैंने आपको पहले भी बोला था कि बेस केसेस पे अभी सेकंड क्वेश्चन को हम सॉल्व करेंगे। अभी हमने फर्स्ट क्वेश्चन इन्वर्ट ट्री किया है। सो सेम ट्री क्वेश्चन है, अभी बताता हूँ पहले। बट बेस केसेस, या जैसे कि मैंने आपको अभी 5-10 मिनट पहले बताया था कि आपको रटना नहीं होता कि रिटर्न जीरो ही करना है, या सिर्फ रिटर्न ही करना है, या सिर्फ क्या करना है। ठीक है। द थिंग इज, कॉमेडी शो चल रहा है यार, अरे रियली सॉरी यार, थोड़ा सा ही बोला था। ठीक है। द एक्चुअल थिंग इज कि जब भी आप बेस केस के बारे में सोचते हो, वेन एवर यू आर थिंकिंग अबाउट द बेस केस, अगेन यू हैव टू ड्रॉ द डायग्राम एंड थिंक अबाउट इट। जैसे यहाँ पे व्हाट आई थॉट इज वेरी सिंपल। व्हेन यू आर एट नल, नल हैज नो लेफ्ट एंड नो राइट। लास्ट क्लास में बताया था आपको। सो नल्स इन्वर्टिंग कैन नॉट बी डन, so you will return. सिंपल। दैट्स इट। दैट इज इट। अब जैसे 30 है, 30 का लेफ्ट नल है, राइट 60 है। बट हम स्वैप करेंगे, स्वैप हो सकता है नल। ठीक है, बट नल का कुछ स्वैप नहीं होगा। अब जैसे मैथ्स वाला क्वेश्चन था, तो उसमें हमने सोचा कि क्यों बेस केस क्या है, नो ऑल। ठीक है। इट्स ओके सेल्फा गणेश, आई एम एक्चुअली टीचिंग इन इंग्लिश ओनली। ठीक है, थोड़ी बहुत कॉन्वर्सेशन चल रही है हिंदी में। इट्स ओके। ठीक है भाई। आईडी दे दो भैया, आईडी दे दो। गीकी राघव है भाई आईडी। एनीवेज, हम आ जाते हैं सेम ट्री पे। ठीक है। हम आ जाते हैं सेम ट्री पे। सो सेम ट्री क्या क्वेश्चन है? बेसिकली आपको यार यहाँ पे दो नोट्स दे रखे होंगे, एक बार देख लेते हैं वैसे तो। लेट्स जस्ट चेक द सेम ट्री क्वेश्चन in Geeks for Geeks platform, and let's read the problem statement first, because A better thing is to actually same tree GFG. ठीक है, आइडेंटिकल ट्रीज है, अच्छा है यहाँ पे, ठीक है। तो देखो अब से व्हाट यू हैव टू डू इज go here, like you are solving a problem, you are filling this function, the return type is boolean, okay, and you are given two nodes r1 and r2, root 1 root 2, whatever you call them. You have two trees. Now you have to tell if the both the trees are identical or not. For example, 1 2 3 1 2 3, the values are identical or not. So these three trees are clearly identical. If we have two trees 1 2 3 1 2 3, are these two trees same? Please tell me. Are these two trees same? No, they are not. They are invert of each other. They are not same. They are not same. Okay. So the answer is false. The answer is true over here. And obviously, the structure of these two trees are same. If the structure is different, in this case, the entire structure is different, 1, 2, and 1, 2. Again, the output is false. It looks like these are same trees. Please, in the chat, लिखो एक बार and बताओ if you are understanding this. Why are these two trees not the same? Because it is one, one's left is two, one's right is null. Here one's left is null and right is two. They are invert of each other. They are not same. Okay, they are not same. They are not same. आइसो मेरे हमारे यार, अभी भी उभरे नहीं हो क्या आपने जेई वाले उससे? इतना दुख मिल गया था क्या, इतना दुख हो गया था कि रैंक नहीं आई थी या फिर आईआईटी वाईटी नहीं मिला था, एनआईटी नहीं मिला था? अभी तक आइसो मेरे समय, सॉरी, दिल पे लगने वाली बात है तो। ठीक है, वन रूट नोड है ना, यस प्रिया, वन इज द रूट नोड। रोल नंबर इज इक्वल टू रैंक। नहीं नहीं, इतना भी नहीं यार। हाँ, मैं मेरी तो नहीं आई थी, मेरी तो ठीक आई थी यार। अब अपनी बातें करो, मेरा तो फोन नंबर नहीं था भाई। मेरा डिसेंट था। ठीक है, okay, once again example. So Sahil, what I'm trying to say is these two trees are exactly same. One is root, one left is two, one right is three, one left is two, one right is three. These are two trees. This is one tree and this is one tree, right? Here these are two trees. We are given two trees, node r1 r2, the root of two trees. We have to check and give an answer in terms of true and false, sahi ya nahi, if the trees are identical or not. These are not identical. They look identical, 1 2 3 1 2 3. They are mirror images of each other, yes, but they are not same because 1 2 3 1 3 2, they are different. I am a beginner learner of DSA. Could you please explain how to understand constraints, sir? So Purnima, I would request you to join any sort of batch of Geeks for Geeks, wherein we will make you guys learn from the very basics. These three sessions are of trees only. Yes, I'm teaching from the very basics, but from trees, right? In any sort of batch or YouTube series, if you will watch, you will get the idea. ठीक है? And also, guys, my batch is coming very, very soon. ठीक है? So my DSA batch is coming very, 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 very soon. I will be teaching live DSA, very, very affordable as well. Okay? So good thing for you guys. अगर स्टार्टिंग से पढ़ना है किसी को तो ठीक है। तो इधर आ जाते हैं यार, लेट्स मूव ऑन टू दिस क्वेश्चन। कैन एनीवन टेल व्हाट हाउ वी कैन सॉल्व दिस क्वेश्चन? प्लीज टेल मी इन द chat. Yes, you can join the batch if you want to become a pro. So Sharad is giving the answer. I think Sharad knows every single thing. ठीक है? So if P and Q are same, return इससे, ओ ओके ओके ओके, थोड़ी सी गलती कर दी आपने, बट चलो देखेंगे। हम्म, नहीं नहीं, सही किया सही किया। हम्म उर्विश is also giving, I think, right answer. ठीक है, ट्राई डीएफएस बोथ एंड कंपेयर, ओके, लीनियर सर्च, नहीं नहीं, इधर आ जाते हैं। थोड़ा हेडेक हो रहा है यार एक तो मेरे को। ठीक है, लेट्स सी टू ट्रीज which are similar, and then we will see two trees which are not similar, and then we will see how can we solve the questions. ठीक है, मान लो ये एक ट्री है। ठीक है, 10 20 30 40 50 60, 10 20, 30, 40, 50, 60. We have these two. मनु गौतम इज सेइंग आज ही 10,000 कर। अरे भाई, आई हैव नॉट पेड मनु गौतम फॉर यू गाइस टू फॉलो मी। यू कैन फॉलो मी फॉर योर ओन satisfaction. I have not paid Manu Gautam. Manu is doing my free PR. Thank you, Manu. ठीक है, थैंक यू मनु। मनु इज डूइंग माई फ्री PR। चलिए इधर आ जाते हैं, मुद्दे पे आते हैं। तो ये दो ट्रीज है। एज वी कैन सी दीज आर एक्चुअली प्रिटी सेम, दे आर एब्सोल्युटली सेम, कॉपी पेस्ट किया है वैसे मैंने। हाउ वी विल चेक, हम देखते हैं। तो वी आर गिवन टू ट्रीज, two roots R1 and R2, right? How we will compare them is something like this. We will traverse the entire tree, for example, in pre-order, but we will do the things together. We will traverse together, साथ में चलेंगे। जैसे सबसे पहले R1 is here, R2 is here. So what we will do is हम compare करेंगे, क्या ये दोनों बराबर है? Are these two things same? Yes, R1 value, R1 data and R2 data are same. They are 10. ठीक है, वेरी नाइस। इफ दे आर डिफरेंट, फॉर एग्जाम्पल इट वॉज 100, इट वॉज 10, ठीक है, इट वॉज 100, इट वॉज 10, रेस्ट ऑल आर सेम, आई डू नॉट केयर अबाउट रेस्ट। इफ इवन दीज आर डिफरेंट, द आंसर इज फॉल्स immediately. So whenever the values are different, return false immediately. Then the second thing will be something like this. These are same, go to left and right. Firstly we will go to left of both. मतलब again, the actually what we will do is we will break the question into three parts. Can anyone tell the three parts of any tree in the chat? Yes, Charitha is right. Root, left subtree and right subtree. Priya is also right. Ayush is right. Again देखो, इस क्वेश्चन में मैं एक बारी के लिए थोड़ा सा घूम गया था अभी। एक तो मेरे सर दर्द भी हो रहा है, ऊपर से थोड़ा सा मुझे लग रहा था कि कैसे ये सॉल्व होगा, राइट? बट मेरे दिमाग में बजी घंटी। देयर वॉज अ बेल दैट रैंग इन माई हेड which said root, left subtree and right subtree, right? So जब भी कभी खो जाओ, whenever you are lost, think about root, left subtree and right subtree. So we will compare the root of both. Are they same? Yes. Then recursion will compare the left subtree and right subtree. If they are same, then well and good. Then recursion will compare left subtree of first tree, left subtree of second tree. If they are same, well and good. अगर सबसे पहले फर्स्ट एंड सेकेंड, इफ दिस इज फॉल्स, दो बोथ द ट्रीज आर नॉट सेम. इफ दिस इज फॉल्स, these are not same, the trees are not same. If the right sub trees are not same, the trees are not same. Very, very simple. So recursion will do everything for us, right? So let me just move to the coding screen first. The concept is very similar. It is always root, left subtree and right subtree. Okay, so again what I said is, firstly I'll compare three things. First thing to compare is the where we are standing currently, the root. So if R1 dot, here there is a here there is data. So in Geeks for Geeks it is not val, it is data. Anyways, it does not matter, it is data. Okay, so if this data is not equal to, please remember, if this data is not equal to, if it is not equal to R2 dot data, then immediately we will return false. Okay, think about the false part, not the true part right now. If everything is true, then only we will return true. Okay, if everything is true, then only we will return true. Now the signature of the function, the return type, actually not signature, signature to ye hai, name hai. The return type of the function is Boolean. So this entire function is identical, is returning a true or a false. Now I will ask recursion, is the left subtree of R1 and R2, are the left subtrees same or not? And I will store them in a Boolean. I will store them in the Boolean. Is left same? Is both the left subtrees of R1 and R2 same? So how can I find it? I will say recursion Baba, idhar aa jao. Recursion will do everything. Recursion will do everything. So what is the actually left subtree of R1? It is R2, R1 dot left and R2 dot left, right? Are you guys understanding? Please write in the chats. Chat में लिखिए. Okay. What I'm trying to do is, firstly, I compared the data. If they are false, return false. Otherwise, आगे बढ़ो. Then I will check the left subtrees of both the trees. Is left same? So I will call recursion will give me the answer in true or false. So true or false can be stored in a boolean. Okay. I will store if is left same in this particular function call. Similarly, now, I will also find out is the right subtree of both the trees. Please remember, of both the trees, are they also same? ठीक है. So it will come out to be true or false or something like that, right? ऐसा ही कुछ होगा, ऐसा ही कुछ होगा. Now we will return, now we will return is left same and, please remember, and and is right same. ठीक है. And is right same. Okay. So if this is true and this is true. Now please remember ये मैंने क्या किया एकदम से. पहले मैं आपको थोड़ा सा समझा देता हूँ. Let me make you understand the thing. If this is true and this is true, the AND operator makes sure that true and true is true. If one of them is false, the entire expression, this is an expression actually. Let me put brackets. ठीक है. It makes sure that if one of them is false, the entire thing is false. And because I told you, each of three things should be true. If anything is false, I will return false. Actually, we can do one more thing, that after this line, we can write if this is false, return false, this is false, return false. And last we can return true if everything is true. Please tell me in the chat. Got a silly doubt what happens when there is a null value? I'll tell you. अभी पहले थोड़ा सा आना है null के लिए. Okay. अब आते हैं base case में, which is important, very important. This is not the base case, and what we can do is, instead of using the variables, now we can just AND this and this. Okay, थोड़ा सा बाद में करेंगे उसको, but I think you are understanding what is happening over here. You can do one more thing. Is left same, like if is left same is equal to false. If this comes out to be false, then return false. And similarly, you can do it for right, but it will be a lengthy process. I think इतना if else आपको आना चाहिए यार. इसको हटा देते हैं, वरना आप क्या ही कोडिंग पढ़ रहे हो. ठीक है, वेरी बेसिक्स कंडीशनल्स में पढ़ते हैं. ठीक है. Now the base case is, what if R1 is null and R2 is null? Now actually one more thing can happen. R1 can be null and R2 can be not null. Or R2 can be null, R1 can be not null. Because if the trees are not same, they can be structurally not same as well. Like in this case, I compared the root, they are same. Then I compared the left subtree, it is true. Here the left subtree is null. So if one of them is null, please remember, if one of them is null, the other one is not null, I will return false. Very, very important. And if both are null, they are same, I will return true. Okay. So if please remember, if R1 is also null and R2 is also equal to null, I will return true, because null are same, both null are same. But if one is null, another is not, then it is a clear indication that the trees are not same. So I will return false in that case. So if R1 equal to null and R2 is not equal to null, then I will return false. And similarly, there are three base cases. I can reduce them to one also. I'll tell you. If R1 is not null and R2 is actually null, then also I will return false. Please tell me in the chat if it is understandable for you guys. There are three base cases, technically speaking. This is also a base. Anyways, okay. If both are null, they are same. So I'm returning true. If one is null, another one is not, it is a clear indication that the trees are not same. The trees are not same. Okay. Now what we can do is, we can actually reduce these two things, because these two statements, what they actually mean is if one of them is null, right? We can reduce them in this statement, something like this, using or. Now, please understand the order of this statement below the above statement is very important. If R1 is null or R2 is null, actually what this means is either one of R1 and R2 are null or both are null. But the condition of both are null is already considered in the top case. So if both are null, the return statement will hit and it will give true. None of these things will hit. It will be tata, goodbye, gaya khatam. Okay? If this is not hit, right? If both are not null, then only we are coming here. So now we are checking if one is null or not. If one is null, I will return false. Okay? I will return false. This is the thing. Okay? This is much cleaner. Can we do after return true the next two base case as return false? वही किया हमने दिया मुखर्जी. We did that only. We did that only. Okay. And the previous thing that I did, where there were two if statements instead of this single one, then we could have rearranged the three if statements in any order. It won't matter. But here it is very important. You cannot cut and paste it below. No, this is not right. Okay, this is the right thing. Also, if you want to shorten the code, what you can do is it won't look cleaner, to be honest. But if you want to shorter the code, like shorter the length, remove two lines, you can just do these things. It is not the cleanest of codes right here, but it is not wrong. So this is the answer. Technically speaking, it is a 2-3 liner code. Okay. Awesome teaching. Very nice. Can it be reduced to 1? It can be, technically speaking. Return root 1 is equal to root 2. Yes, you can actually do that. No, actually, when you are comparing, Chopra, when you are comparing root 1 and root 2, na, they are nodes. So they are never equal. Please remember this. R1 and R2, I am not comparing R1 and R2. I am never comparing R1 and R2. I am comparing their datas. Okay? I am comparing their datas. We can return early if left subtree return false. Yes, Ayush, like you can do that thing as well, जो मैंने पहले भी करके दिखाया था. Instead of returning these two things, like computing this, and then if one of them is false, the return will be false. You can do that thing also कि जो मैंने पहले आपको करके दिखाया था कि first compute the is left same, then return false. If it is false, then compute the is right same, and then and then lastly you can return true. ठीक है, you can return true. This will avoid redundant calls. Not really, Ayush, not really. It won't. I'll tell you why. In Java language, it is not like ki, for example, I am getting your doubt. Ayush's doubt is very nice. Please, students, please listen to this doubt. His doubt is, for example, if this call is false, right? So befaltu mein we are actually computing this call as well. But this is not the case. If the first call comes out to be false in Java language and C++, and if this is false and there is an AND operator in between, so a concept named short circuit happens. The physics वाला short circuit नहीं, यहाँ वाला short circuit. Short circuit में होता क्या है? If there are two conditions, even if in if else statements, if the first condition is false and there is an AND, so it does not matter if the second condition is true or false. It will never check the second condition because false and false is false, false and true is also false. Okay, so it won't check. And similarly, whenever there is a or operator in between, for example, this is or. So if R1 is null, it comes out to be true. R1 is null. Then this or condition, and then the compiler sees that this is or. It will not check this one. This condition won't be checked. Okay. तो short circuit कहते हैं इस चीज को. So this is same tree. Now there is a homework for you. The homework is also very, very simple. The homework is सिमेट्रिक ट्री। ओके, तो सिमेट्रिक, गिग्स फॉर गिग्स पे है ना भाई, हाँ। ओके, थैंक यू सरिता। मिरर इमेज ऑफ इटसेल्फ, ट्राई इट ऑन जीएफजी प्रैक्टिस, ठीक है। सो दिस क्वेश्चन इज वेरी वेरी सिंपल. You will be able to solve this question if the questions that I just showed you, which was identical trees and the invert trees, both of these, okay, the mirror tree and if you know identical tree, using these two codes, this is a piece of cake. दिस इज अ पीस ऑफ केक. ओके, लेट्स सी कि कितने बच्चे यार तुम में से समझ सकते हैं इसको. लेट्स सी हाउ मेनी ऑफ यू स्टूडेंट्स कैन अंडरस्टैंड. आई विल रीड द प्रॉब्लम स्टेटमेंट. सिमेट्रिक ट्री, given a root of a binary tree, as you can see you are given just one root, there is a single tree, you have to return boolean. Okay, so you are given a tree, a binary tree, you have to return a true or false. Your task is to check whether the tree is symmetric or not with respect to the root node. Please remember. ठीक है, सिमेट्रिक मतलब जो रूट नोड है उससे आप एक लाइन बनाओ बीच में. हमने एक लाइन बनाई, आप देख सकते हो रूट नोड के रिस्पेक्ट में पूरा ट्री सिमेट्रिक है आपस में. कैन यू नॉट सी दिस थिंग? लाइक द लेटर ए इज सिमेट्रिक, बी इज नॉट सिमेट्रिक विद रिस्पेक्ट टू द मिडल लाइन. ओके, now this is not symmetric although it looks similar, 1 2 3 1 2 3, but this is not symmetric. Okay, so let me show you the iPad screen now and let me teach you. ठीक है, प्रमोशन करेंगे हम फुल. और क्वेश्चन 3 इज सिमेट्रिक ट्री. अगेन अ वेरी वेरी सिंपल प्रॉब्लम. ठीक है, अ वेरी वेरी सिंपल प्रॉब्लम. तो सिमेट्रिक कब होता है ट्री? सिमेट्रिक कब होता है ट्री? हम रूट के हिसाब से सिमेट्रिसिटी को चेक करते हैं. वी चेक द सिमेट्रिसिटी विद रिस्पेक्ट टू द रूट. ओके, तो रूट की कुछ भी वैल्यू हो सकती है. द वैल्यू कैन बी एनीथिंग, फॉर एग्जांपल 10, 20, 20, 30, 30, 40, 40. सो विद रिस्पेक्ट टू दिस लाइन these trees are similar. The root can be anything, it does not matter. Okay, root can be anything. So please tell me how to solve this particular code using the combination of two questions that I told you. Invert, mirror a tree, mirror a given tree, and checking if two given trees are same or not. You can do this question very easily, very easily. The symmetric means values are same, or the shape and values both. Okay, if data is different, for example, if I do something like this, ki this is 50, so the answer is false. This is not a symmetric tree. Or for example, the thing is something like this कि ऐसा कुछ है आपके पास, you have something like this कि again this is 30, again the answer is false. ठीक है, this is not symmetric. Okay, and if there is something like this कि you have here 30, now are the two trees symmetrical? No, because this is null. So null is being compared to 30. Okay, again, if this is not here and the value is different, the answer is still false. Okay, now tell me in the chat please यार, you guys are not chatting. वैसे बड़ी chatting चलती है तुम्हारी. पता है, the nice thing is that you guys are not actually heavy spammers. You are nice students. You are very very nice students. And before moving forward in the lecture, आगे बढ़ने से पहले एक बात आपसे बोलना चाहता हूँ कि थैंक यू वेरी मच यार. आप पिछले 2 दिन से आ रहे हो, अच्छी खासी तादाद में आ रहे हो, 500-600 बच्चे लाइव जूम में आ रहे हैं. एंड आई एम वेरी हैप्पी कि आप लोग पढ़ रहे हो. बिकॉज 4 साढ़े 4 साल हो गए मुझे, अराउंड 4.5 से 5 साल होने वाले हैं इन एडटेक. ठीक है, इन इन दी एंटायर एडटेक स्पेस. एंड इससे पहले भी मैं जहाँ पे था तो आई यूज टू टेक सम लाइव क्लासेस. And whenever I used to take live classes, specifically I took live classes for class 12 students. So it was horrible because a lot of students were, chatting in between themselves. For example, there was, for example, यहाँ पे if I take some names, okay, so uh, Priyanshu, and let me take a name of a girl. Okay, Anjali. ठीक है. No offense, I'm just telling you the story. What happened in my previous place was the students were something like this, that Priyanshu would constantly say, अंजलि अपनी आईडी दे दो, अंजलि बात कैसे करें हम, अंजलि ये अंजलि वो. सो थोड़ा ऐसा सीन था. आई एम रियली हैप्पी कि आप लोग यार पढ़ रहे हो यार, और सच में पढ़ रहे हो. एंड आपका जो रिटेंशन है वो भी बहुत अच्छा है. ठीक है. 500-600 बच्चे अगर आते हैं, 500 550, तो 450 बिल्कुल 2 घंटे होने वाले हैं. एंड यू आर स्टिल विद मी. ठीक है. देयर इट वॉज लाइक कि 500 से 100 150 हो जाता था, क्योंकि आधे बच्चे सिर्फ बगैती करने आते थे. सो या, आई एम रियली लाइकिंग यू स्टूडेंट्स. ओके. आई एम क्यूरियस, अंजलि ने आईडी दी? पता नहीं यार एक्चुअली. वो तो अंजलि से ही पूछो. ठीक है. अगेन सॉरी प्रियांशु एंड अंजलि, मैंने बस रिलेटेबल बात बताने के लिए बताया था तुम्हें. ठीक है. यू स्टूडेंट्स आर रियली नाइस. ठीक है. मैं बहुत खुश हूँ, आप अच्छे स्टूडेंट्स हो. एंड आई विल रादर टीच लेस नंबर ऑफ स्टूडेंट्स हु आर गुड, rather than teaching a lot of students who are not even there for study. Okay. हम्म. ठीक है. चलो अब चैट में बता दो यार, क्या इसका एल्गोरिदम क्या है, नॉट द कोड, जस्ट द एल्गोरिदम, कि व्हाट विल बी द स्टेप्स टू फाइंड आउट इफ एनी ट्री इज सिमेट्रिक और नॉट. राइट इट इन इंग्लिश लैंग्वेज. हाँ, बहुत कम होगा यार जो भी होगा लाइफ का. यस, आई टीच बोथ. अजीत, आई टीच बोथ. सोनू इज सेइंग एक्सप्लेन अगेन. अरे सोनू, आई हैव नॉट एक्सप्लेन द सॉल्यूशन. अभी आई विल एक्सप्लेन. अभी हम आस्किंग यू, आर यू गाइज हैविंग एनी आइडिया और नॉट? आई विल एक्सप्लेन. Priya is saying -101. I'm not getting you. So Anjali is saying, Anjali is actually giving the answer, guys. Anjali OP in the chat. Invert left subtree and check the left is equal to right. Very, very nice, yeah. Very nice. Absolutely perfect. Kudos to Anjali. ठीक है. चैट में हो जाए भाई अब. पुराने टेक की यादें आ रही है, तभी ऐसी बातें हो रही है. ओके. अंजलि ओपन इन द चैट. आई डोंट नो अबाउट द एनसीईआरटी टेस्ट. जीएफजी का ही है तो आई विल आस्क. मोहित ओपी क्यों भाई? मोहित ओपी नहीं है अभी. मोहित, तुमने आंसर नहीं दिया है. मोहित नॉट ओपी. अच्छा, दिया है. अच्छा, एक्चुअली ओपी मीन्स ओवर पावर्ड. ओजी मीन्स ओरिजिनल गैंगस्टर. एनीथिंग. द कोर्स इज स्टार्टिंग इन जून समथिंग. अगर आप में से बहुत सारे स्टूडेंट्स पहले से इंटरेस्टेड हो जाते हैं तो कोर्स हम जल्दी लॉन्च कर देंगे इनफैक्ट. हम्म. ठीक है. द कॉन्सेप्ट इज वेरी सिंपल. द स्टेप्स. स्टेप नंबर 1, इन्वर्ट द लेफ्ट सब ट्री स्लैश राइट सब ट्री. आपकी मर्जी है. जैसे अभी के लिए मैं लेफ्ट लिख देता हूं, लेकिन दोनों में से कोई एक, ओनली वन. इन्वर्ट एनी वन ऑफ द ट्रीज. ओके. इन्वर्ट एनी वन ऑफ द ट्रीज, लेफ्ट सब ट्री और राइट सब ट्री में से ओनली वन. वॉट एवर, बट ओनली वन. इन्वर्ट द लेफ्ट सब ट्री फॉर एग्जाम्पल, एंड देन अप्लाई इज सेम ट्री नाउ on left subtree and right subtree. Okay. So what I'm doing is, for example, this was the tree. This is the left subtree. First of all, I inverted this tree. So I made a change. There was initially null. So what I did is I inverted the left subtree. It is done. It was a very small 3 tree. It could have been a bit bigger tree as well. Now what I did is I checked the left subtree and the right subtree and applied the is same tree function. दोनों कोड कर चुके हैं हम. Of course, if they are same, the answer will be true, and I'll return the answer. Please tell me in the chat if it was a good idea. Also, we can go horizontal distance. Not really, I'm not sure about it. Students are saying again, please. Ganesh is saying not optimal. No, it is optimal, Ganesh. Because if I'm inverting a tree, left subtree, technically the time complexity is big O of n by 2 or big O of n. The half of the nodes are getting inverted. And then when I'm comparing also, the time complexity is big O of n only or n by 2. So in total, the complexity is big O of n only. Okay. But we are introducing space. No, we are only introducing space, Ganesh, if we are firstly making a copy of the tree and then inverting in that. So if in interview it is being asked that if you are solving this question, please make sure to not modify the tree. Okay, even in that case, what you can do is the interviewer can say that, okay, you solved the question. You told ki haan, this was a same tree or not. But the thing is, ki you changed the tree. So it's okay. After returning, in fact, store the answer before returning. And what you can do is then again invert the left subtree. Because if you invert two times, it will become the same. Okay? Yes, you can re-invert it. Are you guys getting it? What I'm doing? Let me just back the question. Okay. So this was the question. This was the question. Okay. Let me make the trees actually symmetric. So this is a symmetric tree, as you can see, 10, 20, 20, 30, 30, null, null. Right? This is a symmetric tree. Okay. This is a symmetric tree. So what I am currently doing over here, or what we can do is, I'll make some values also for you guys, 40, 40. Of course, these are symmetric. The steps are only two steps. Firstly, make two functions. We have already made the functions. We have solved invert mirror tree or invert tree, and we have solved if same tree passing two nodes. Now, what we will do is we will invert one of these two trees, not both, one of these. For example, I did invert the left subtree. So after inverting, it became something like this. Okay, the tree actually changed. Please look very carefully. The left subtree is now changed. It is inverted. Now, as you can see, the left subtree and the right subtree are now exactly same, 20, 20, 40, 40, 30, 30. So now I will check if they are same or not. If they are, then the answer is true. Sharad is saying, I don't think we need to invert. Yes, that is the second method. Please wait, Sharad, please wait. And that is very nice कि आपने answer लिखा है. ठीक है? We can actually change the things as well. Okay, we can actually change the things as well. But anyways, we can apply recursion and all. What I am trying to tell you is sometimes we solve some particular questions and then apply on the third question. Let me just write it in the code, and I will not write anything. I will just copy paste. अब आएगा मजा आपको. ठीक है, ये देखिए. I have to return is symmetric or not. So what I will do is, let's go to the mirror thing. This was the mirror thing. I copied this code and I actually pasted it over here. Also because here there is public static as well. So it is recommended to just add it over here. Okay. This is one code. Firstly, I will mirror any left subtree or right subtree. So root dot left. Also, one more thing. If root is null, null का कोई left और right नहीं होता है. ठीक है? तो if root is null, this can also happen. The root can be null as well. Let's see the constraints. अच्छा नहीं. Number of nodes are minimum one. One minimum node is there, so you do not need to write this. But you can write it. Okay? You can return true because if the tree is null, it is symmetric. ठीक है? So we will first of all invert the left subtree. Invert the left subtree. Okay, then what we will do is there was a question of identical trees which actually returned true or false as in the trees were identical or not. Okay, if the trees are identical or not. So again, I made this function. Now I passed, I will actually return, I will actually return is identical. I will return is identical roots left and roots right subtree. Okay, that's it. That is the answer. Let me submit. So two-line code, to not exactly two line. I actually solved two questions for that. Acha, it is not working. Why is it not working? Oh, अच्छा मैंने root dot left. Wow. ठीक है. As you can see, it is being passed. Okay. So this was the simple question, which was extension of two questions, the third question. Okay. Now Suham is saying a solution, but first of all, we should see Sharad's solution. Yeah, we should see Sharad's solution. What Sharad is saying, I don't think we need to invert and all. Simply, we can use the below thing. We can make a helper function, return left data equal to right data, and is symmetric util अच्छा लिखा है is symmetric left dot left right dot right and is symmetric left dot right dot left. All right. So let me just dry run the code that Sharad is saying and verify it, and then only we will do the thing. Okay, so this is basically method number 2. We have to check if the code is symmetrical or not. What Sharad is saying is something like this. Again, root के बारे में तो we do not have to be concerned at all. What he is comparing is कि left data and right data should be same for a particular root, right? For them to be symmetric. But at the same time, जैसे हमने we saw that these are similar, that's okay. But now we cannot do something like this that okay, from here we are going to left, here also we are going to left. नहीं, वो काम हमें करना ही नहीं है. इनफैक्ट आई एम रियली सॉरी, एक्चुअली में ट्री ये था. ठीक है, दिस इज अ सिमेट्रिकल ट्री. So we won't go here and here. What we will actually call, it is a very important thing that we need to consider, is we are actually, if this is root dot left, this is root dot right. Now this is left dot right and this is right dot left. We have to compare left dot right and right dot left and left dot left and right dot right. But will this code work for larger trees? The problem is that. And what he is doing over here is simple, that if we are standing over here, we compare these values. Now they can be null as well. One of them can be null as well. Okay, we will return false. That is not a big deal. But then we are calling if they are not null, we are calling their left and their right and checking their things and all. Let me just verify this entire thing for a bigger tree now. And let's check if what Sharad is saying is correct or not. Okay? Because it can be problematic according to me. Maybe. If not, then really nice फिर तो. Okay? So let's make some observations. 30 does not have left right. So 50, 50, 60, 60. Again, this is a symmetric tree. This is a symmetric tree. Okay. So let us use Sharad's algorithm. मैं बता देता हूँ आपको एक बार students. What was the algorithm? We are standing at a particular root. This is the root, for example. This is the root. And what we are doing is, in any root where we are standing, because we want to, actually what Sharad is saying will never work, I think. Let me check. ठीक है. It can work. If it works, then it is really nice. एक बार देख लेता हूँ मैं. Because this is root. At a particular instant, what he is saying is we are comparing the left and right values. Okay, they are same. Well and good. Now we are applying the same is symmetric function. What we applied over here. We are applying that function to what? Because Bunny is saying it works. शरद का कोड देख लेते हैं एक बार. हाँ, अब आपने लेफ्ट और राइट दी ना, यही तो पूछना था मुझे आपसे. एनीवेज, यू गेव लेफ्ट एंड राइट एंड यू रिटर्न इट. ठीक है. अच्छा, ठीक है. सो एक्चुअली इट इज नॉट लाइक कि वी आर स्टैंडिंग एट पर्टिकुलर नोड. We are making a helper function. That's why Sharad said we are making another function. Why? Because we need to compare two values at a time. Okay, to get it to get it to be symmetric. Okay. So what initially we did is we passed root 1, root 2, for example, to the left and right. We check the values if they are similar. Now what we will do is we will apply recursion two times. Like two times is, firstly R1 ko we will make it go to the left, R2 ko we will make it go to the right. Right? Left dot right basically wherever we are ये थोड़ा सा आपने गलती कर रखी है आई थिंक। अच्छा आपने लेफ्ट उसका नाम दे रखा है, तभी मैं समझूं। ठीक है सही है, आपने कोड सही लिखा है, आपने नोड लेफ्ट लिख रखा है उसमें नाम। ठीक है ओके ऑल राइट। सो आई विल कंपेयर इट्स लेफ्ट R1 डॉट लेफ्ट एंड R2 डॉट राइट। इफ दे आर सेम वेल एंड गुड, मतलब आई विल अप्लाई द सेम फंक्शन ओवर हेयर एंड देन आई विल ऑल्सो अप्लाई द सेम फंक्शन ओवर हेयर. Now after that what I will do is I will actually apply, if I am standing at these two nodes, in their right and their left I will apply the code. Okay, this will work very nice. Sharad is absolutely correct. Please tell me in the chat tell me in the chat students कि किस किस को ये समझ नहीं आया. Then I will make you understand what Sharad is trying to say. You can see in the chat also. No, repeat. Okay. अब मैं आपको समझा देता हूँ. पहले तो मैंने खुद कंफर्म किया जो ये कह रहा है वो सही है भी या नहीं, बट इट इज एब्सोल्युटली करेक्ट. So what Sharad did is, if I want to check if the tree is symmetric or not, again the concept is very similar. The concept is similar in the sense that for the tree to be similar, these values are similar, the extremes are similar, these are similar, right? These should be similar. Now in a particular level, they are similar, and so on. What Sharad did is he actually made another function. He made a helper function. The helper function is a very simple function. You can name it anything. And I passed, like initially it was, even if it was R, so I passed its left and its right and make a function and just or maybe it is a symmetric function. This function will tell me if the entire tree is symmetric or not. Okay. Basically, this function will actually tell me what Sharad is doing is he's actually doing something like this key. If the left subtree and the right subtree, are they invert of each other or not? Invert of each other or not? So the question is now this. Okay, I think अब आप students को समझ आएगा. You guys may be able to understand now. The question is, the method is, we are actually we have two trees. We have two trees. ठीक है? The left subtree and right subtree, whatever. We have two trees, right? So we are what we are doing is we are seeing if they are actually invert of each other or not. For that, what we did is what Sharad did, and what I will do is, first of all, compare the two values of, again, these have to be similar. Now the path of doing this, whenever we were checking if the two given trees were same or not, in that case, we were comparing the values. Then we were going to left and right simultaneously. Like if this is going to left, this is also going to left. But in this case, because we are checking if they are invert or not of each other, then whenever R1 goes to left, in that call, R2 goes to right. And then we check if the values are same or not. And similarly, when R1 goes to right, R2 goes to left, and then we check the values and all. And then again recursion happens. Like if R1 was here, R2 was here, again recursion happens. We check the values. Okay, if it is false, it is false. Then we see whenever we are going to left, here we go to right. Okay, so reverse things are happening, and then we are returning the answers. So let me write the code first, then you will be able to understand it in a better sense. And kudos to Sharad for giving us this method. Opposite verification, yes. Harsh is absolutely correct. So this method is not bad. What I did is, it is not bad, but it's all right. Okay, it is not the best. It is not bad, but it is not the best. Okay, so Sharad's method is something like this, that I am creating a helper function. So you can actually comment this or maybe remove this. Okay, एक second यार. ठीक है? Commenting this code, commenting these two lines as well. Actually, what we are doing is we will actually return the helper now. We are making a function, helper function, जिसमें we are passing roots left and roots right. And the concept is something like this. Public Let me copy this code, or maybe let me copy this code. ठीक है, आई लाइक टू कॉपी पेस्ट अ लॉट, मेहनत करने का मन नहीं होता मेरा, ठीक है। तो हेल्पर, इट इज रिसीविंग टू नोड्स R1 R2 नाम दे दिया मैंने, थोड़ा बेटर रहेगा। अगेन व्हाट यू हैव टू डू इज समथिंग लाइक दिस। फर्स्ट ऑफ ऑल, डू नॉट केयर अबाउट द base cases. Yes, if the values of R1 and R2 are not similar, return false. That's true. Okay, now what you have to do is you will return something like this. What you have to do is this: you have to apply the helper function twice. If R1 and R2 are here, you have to compare R1's left to R2's right, R1's left to R2's right. Now recursion will give me that answer. I can store it in something, in a Boolean variable. So Boolean, the first comparison, which I am saying is the extreme comparison, or maybe the this comparison, you can write it as first or whatever it is. So basically first comparison is something like this, कि now recursion will give me the answer of this and this, and obviously you have to remove these things, right? This can be true or false. If this is false, return false immediately, or maybe you can write it afterwards. Now what we will do is we will check. I'm making a variable second, where if I go right, then here I have to go left. Okay, opposite. And I have to check. Now I have to simply return first and second. So if either one of them is false, the total answer is false. Now let's do the base cases, because if the roots are themselves null, or if any of the root is null, I will return false. If both the roots are null, I will return true. So I think I can copy these lines. Okay, I can copy these lines. Why these base cases? Because if both are null, you can return true. If one of them is null, you can return false. Please tell me in the chat if it is understandable. Let me just code it, submit it. And as you can see, it works. Ha, technically time complexity is same, but yes, 2n and n, it is faster. If first becomes false, why we compute second? Meshkat, we actually, yes, here we are actually computing the second. So the better way of doing it is actually not to make the first and second. ये तो मैंने आपको समझाने के लिए किया था मेरी जान, ये मैंने समझाने के लिए किया था आपको मेरे बच्चों। इधर ये देखो, कॉपी करो इसको। Yeah. Now the second won't be computed if first is false. Okay. The second won't be computed. And this will also run fine. Hmm. This is a one pass solution. Yes. Very simple solution. True, true. And we use the helper function. Why? Because this given function has only one parameter. We needed two parameters. Okay. चैट में लिख दो यार सबको, सब समझ आ रहा है या नहीं। 100 बच्चे और भाग गए हैं क्योंकि उनको लेट हो रहा होगा, खाना खाना होगा। And I think you guys can now have dinner. If you haven't had dinner, the class is done for today. Uh, some questions are not being completed, which I wanted to complete it today. The diameter of given tree, balanced binary tree. I will do it tomorrow. Okay. Are you guys understanding everything? Are you guys understanding everything? Please tell me in the chat. Write in the chat. मजा आ गया, ठीक है। सो अंजलि ओपी नहीं लिखना आपको चैट में, यू हैव टू राइट मजा आ गया, ठीक है। यस, अटेंडेंस इज गुड इनफ। ओके, मजा आ गया। एंड एक्चुअली यू कैन टेक्स्ट मी ऑन इंस्टा एंड से मजा आ गया, ठीक है। होमवर्क आज है नहीं इतने, दे देंगे आपको होमवर्क भी बाद में। थैंक यू। थैंक यू फॉर अटेंडिंग। Bye. Good night.